the NASA Administrator, Michael Griffin, who is to my left. To his left is NASA Deputy Administrator, Shanna Dale. So we have a treat for the media this morning and the folks, our viewers that are watching, to have both our two senior leaders here to discuss today's events as well as any other questions that the media wants. As protocol and standard procedure, I ask that when you ask your questions, please identify who you are and which affiliate and who you work for before, and please direct the question to a particular person when you ask it. Also, please turn off all your phones and BlackBerries and those types of things as well. All right, appreciate it. Before we get started, let me turn to NASA Administrator Michael Griffin.
Well, as you've come to expect from me, I have no real remarks. It's a great day. We're glad to be here. This is a real milestone event for NASA, and I look forward to taking your questions.
This is the first launch that I will attend coming in as Deputy Administrator of NASA. I came over in mid-November, so I'm very excited to be here. It's an exciting mission, and we're looking for a great day today.
Terrific. Thanks, Shanna. Thanks, Mike. All right, we'll go ahead and get started with your questions. Let's start off with Craig right here in the front.
Good morning. Craig Cavalt with Aviation Week. Big picture, not necessarily focused on this year's coming budget. How would you assess the overall health of the robotic planetary program, given overall budget realities in the coming years? And down to the more specific, your confidence in cost and schedule for Mars Science Lab, which I believe is probably your biggest near-term new project.
Overall, I think all components of NASA will continue to be healthy. You'll see that the NASA is fully supported, and the planetary science program is doing well. With regard to Mars Science Lab, that gets into specifics that I'm just not prepared to go into at this time, Craig. Mars Science Lab obviously is our next big mission to Mars. We will design a mission that fits the budget.
What can you tell us about the prospects? I'm sorry, Mike Schneider, Associated Press. What can you tell us about the prospects for a May shuttle launch, and do you see anything right now that would prevent a May shuttle launch?
I'd rather use this press conference to talk about Pluto and New Horizons, if folks didn't mind. But with regard to May, we are still targeting May for the shuttle. We will shortly be gathering within the shuttle program to pick a specific date. As I sit here today, we think that date will be something in May, and if it slips to July, it slips to July. We launch when we're ready, and not before.
Dan Billow, WESH-TV. I do have a shuttle question. I'd just like to ask you if you could tell us what you need, what NASA needs to fly these 18, 19 missions that you've got on the schedule. In the current budget environment, can you do that? What do you need to make those missions happen?
What we need is to stay with our average statistics over 25 years of shuttle flights. As of April 12, 2006, NASA will have been flying the shuttle for 25 years exactly. We will have flown to that point 114 missions in 25 years. That works out to an average of 4.56 missions per year on average, even taking into account 2 accidents and all the downtime that we have had. So when we return to flight, it will be with 3 fresh orbiters out of depot maintenance. It will be to return to flight with greatly increased knowledge that we have never had before, and yet all we have to do is execute our average performance over those 25 years in order to be able to complete the station. It has been a problem getting back to routine flight, to understand what has caused the phone to come off and how to mitigate it. We think we're there after that one test flight last August. We think the second one will bear us out, and then we expect to get going and finish the station.
I would like to remind everybody that this is a New Horizons press conference, so if you can ask some of those questions as well, that would be appreciated.
I hadn't thought we were restricting my press availability so much, but you guys are being forced to resort to this as an opportunity to ask about the shuttle.
Bill Harwood.
Harwood, CBS, but this isn't about the shuttle, but it's about space science. I just wanted to follow up on Craig's question. A lot of the science team is here for New Horizons. Obviously, there is a tremendous amount of concern, and I'm stating that from what I hear from scientists, that Moon Mars is going to really whack the science program in the years to come. I mean, can you just expand on what you said to Craig, or do you have any reassurance to give that community on what's coming down the road after your AAS speech and all of that? I'm just curious.
We are not, in your words, we are not whacking the space science program to pay for human exploration. This is not The Sopranos. We don't whack people or programs here. Yes, we have, of course, in this nation. I do not need to be the one to tell you this is a difficult budgetary environment. NASA is not looking forward or expecting any gifts of robust growth from either the administration or the Congress. We expect to keep approximately the funding we have, which will essentially be a very low growth funding profile, and therefore all of the components, each separate component of what NASA does, can expect to have at best only modest growth. The difference between cuts and modest growth, I guess, needs to be explained to people. I think we're doing well, and within NASA, the space science program is doing well and will continue to do well.
Good morning, Peter King of CBS News Radio, and I'm sorry I've got to get back to the shuttle, and Supposing you do not fly by May or July, and it keeps going into the fall and next year, at what point do you start, if you will, whacking flights in order to get the required flights you need by the time the shuttle's retired in 2010?
I'm sorry, you're into speculation, and I'm just not going there. We're planning for a flight in late spring or early summer. We believe that it's going to be a good one, and then we'll be back on the road to success. If we don't have success, then we'll have to rethink.
Let's go right up front here.
Robert Goss, Interspace News, and I actually have a planetary exploration question.
Oh, be still my thinking heart.
Does NASA intend to continue this trend towards smaller, mission-specific spacecraft a la New Horizons, or perhaps return to the larger space cruiser-type missions a la Cassini?
Well, NASA will do both. New Horizons is the first mission in our New Frontiers line, which builds and expands upon the Discovery line, which, as you know, is capped in the range of, I don't know the exact number, but around $400 million in current dollars. Discovery, first implemented under then Associate Administrator for Space Science, Wes Huntress, and a good friend of mine, has been a marvelously successful program. And yet the cap does cause us to restrict missions to a certain size. New Frontiers raises that cap, allows us a substantially increased science portfolio for a given mission, yet without opening the purse strings. So I think it's a very good plan. I'm frankly thrilled with it. The folks who have planned space science for us in the last few years have done a great job. That said, there will always be a need for missions which are larger than can be contained in a cost cap mission. I don't think we can do James Webb Space Telescope on a cost cap, just as one example. We could not have done Hubble Space Telescope on a cost cap. There's no one in the country raising their hands saying, in retrospect, I don't think we should have done Hubble. So there will always be a need for missions which just simply cannot be contained within a cost cap. Those missions have to be few and far between. They come obviously on a less frequent basis. They need to be missions that are so compelling that spending a few $1 billion on one continues to attract broad support, because without that broad support they won't happen. But there are such missions, and NASA will continue to do them. We could not have done what Cassini is doing on a cost cap.
Patrick Churchill at Central Florida News 13. I wanted to ask you about the budget cycle that's about to come up before Congress. There are a number of members of Congress that have questioned funding NASA to full levels that you all would want in the wake of Katrina, with the Iraq War, things like that. How can you be confident that at the end of the day you'll be able to win them over?
Budget questions I'm going to defer into the budget press conference that I promise I will be giving on the 6th of February. It's premature for us to be discussing the fiscal 07 and beyond budget. Sorry.
Irene.
Irene Thoughts with Reuters. I seem to remember when the Project Prometheus was rolled out a couple of years ago, that the DOE supply of the RTGs was almost at an end. I know the RTGs on New Horizons was reserved, and I don't think that there was anything else left. And in light of the cancellation of Prometheus, could you talk a little bit about what you're looking at farther downstream for these missions that cannot use solar energy?
Well, first of all, Prometheus would have used a nuclear reactor, not an RTG, and so we're mixing nuclear components here. In fact, NASA will be using an RTG for the Mars Science Laboratory. So this is not our last RTG mission, and it is far from our first. Cassini, Galileo, many other Voyagers, many others before that have used RTGs, and many will again. Production of RTGs within the Department of Energy right now is limited, and steps are being taken to address that. We don't fly them often enough that it's a problem right now. So again, Mars Science Lab, our next mission to Mars, will carry an RTG.
Frederick Castell with BBC World Service. Mr. Griffin, the ESA Columbus module is about to get into KSC. When do you expect to have it flown on shuttle, and what is also your best bet about the number of shuttle flights before retiring the shuttle?
Our best guess at this point is that the shuttle will, as I've said on many occasions, execute something like 17, 18 flights between now and retirement, but it is the date which we are picking, not the number of flights. And my comments earlier on shuttle performance were reflective of average performance in the past, and that would allow us to do that number of flights. As to when Columbus flies in the station assembly schedule, I'm sorry, I don't have that in my head. I just don't know.
Randy Siegel, WSTU Radio. Mike, we've been very blessed recently with a lot of spacecrafts that have gone well beyond their useful lifetime.
We sure have.
And, you know, the Mars rover, Voyager, Pioneer, many others. As a result of that, having to keep them in operation is costing us a lot more money than was originally budgeted for. How do you balance the act?
Well, that's a very good question. When it does cost money to continue to operate spacecraft in terms of deep space net support or other tracking support, and then in terms of the operational crews who sustain them, the mission controllers. And so you have to make, in case of each individual mission, a reasoned decision as to when the science value that you're getting from the mission is no longer worth the money that you're paying. And sometimes you have to turn missions off, and we have done that. We aren't going to be turning off Spirit and Opportunity anytime soon. They're the only two rovers we have on Mars, and we're quite happy with them. There may be other science missions that we would elect to turn off because we no longer see any marginal value to the data in comparison to the cost. I recently decided not to turn off the TRIM mission, the Tropical Rainforest Rainfall Monitoring Mission, because it was the only method that we had to gather the kind of data that allows us to track the formulation of hurricanes and help predict where they're going to go. And I was pleased things worked out the way they did because TRIM was very helpful in plotting the course of Katrina. So we think very carefully before we turn one off, but sometimes you have to.
Hi, Andy Vaughn, Denver Post. Can you talk about the progress of the CEV project and when you think a winning team might be selected?
When the winning team might be selected, I believe we're aiming for source selection in July.
Bids are due in March. I was wondering how long after that team will be selected.
3 or 4 months after that.
John Kelly with Florida Today. Have you had a chance to meet with the science team while you've been down here? And I guess I'm just wondering, you've worked on some of these kind of projects from various aspects before. This particular team is going to have put in, what, a decade ahead, and then they're going to wait a decade to get there. And I just wonder what you think about the sort of dedication, the time commitment. I mean, everybody's talking about the money investment, but the time commitment that these guys put in on something like this seems really a long time.
To make a decision to work in the field of space science is almost the ultimate in delayed gratification. Yes, the principal investigator on this mission, Alan Stern, and the science team, many of them too numerous to mention, who have worked on this have devoted major portions of their careers to it and have a good-sized chunk yet to go before they see the results. It took Cassini from 1997 launch to 2004 to get into orbit, and many years of preparation before that. God has laid out the solar system in a way that requires a certain amount of patience on the part of we who choose to explore it. I have nothing but admiration for the folks who invest this kind of time and effort and energy to make these wishes come true.
The Daily Camera in Boulder, Colorado. I was curious to know, in the mission literature, they talk about if things go well and we reach Pluto and the spacecraft's functional, then there is a possibility of an extended mission to the Kuiper Belt, depending on NASA funding. If things went well, what would the possibility be that NASA would say, well, I don't think we're going to have the money for 2 Kuiper Belt objects?
It is very unlikely that I would be the administrator at that point, and so. In fact, I think I'll be quite lucky to be looking at the divot from the correct side. But I would in this case depart from my normal practice, and I will speculate that we won't turn off a properly operating spacecraft that is penetrating the Kuiper belt. I'm going to give Craig one more.
Yeah, go ahead, Craig.
Craig.
Craig Cavall with Aviation Week on the New Horizons Atlas. The review was quite rigorous, and I believe SMA may have even cast initially a no vote on it. Can you just take a moment and address that process that ultimately approved the vehicle?
Sure. I thought that process was NASA operating with the advice and counsel from the contractor community and frankly our DOE partners. I thought that was NASA at its finest. We had several months of tests, deliberations, and discussions, which culminated in a 4-hour meeting at headquarters last week, where the disposition was that this tank for this mission was fit to fly. Craig, I know that you're knowledgeable of this issue, but for those on TV, I'll recap. We had a situation where the qual tank, which was in notably worse shape, even starting out, than the flight tank, failed qual on the very last cycle of many dozens of pressure cycles to test it, and failed at 94% of the proof pressure. So the question was this tank on this vehicle for this mission fit to fly? And when we looked at the flight loads for this mission profile, which are among the lower that a rocket of this type would expect to see, when we looked at the construction quality of this particular tank, and the fact that it has, and it's after extensive inspections, no cracks or flaws that are detectable at all, we made the determination that it was good to go.
Irene Fox with Reuters. Especially now with the freedom to buy Russian, do you have any people looking into any contingencies for launching space station components on ELVs in case the shuttle's not able to live up to the job?
Well, we're not doing that because there would be, frankly, a great deal of expense involved in converting, any ELV, any expendable launch vehicle into a carrier of station components. And the money that we have available for space station assembly assumes that it will be done using the shuttle. That is the proper vehicle to complete the task, and that's what we're spending our effort and time and money on.
Up the back.
David Briggs, BBC. Does NASA have any plans to send a probe to the newly discovered 10th planet?
Not yet.
Running out of questions. All right, up front, Mike.
Mike Schneider, Associated Press. I know books have been written about this, but if you could, in just a few sentences, we're approaching the anniversary of Challenger, and I was wondering if you could just offer some perspective on, looking back 20 years, what Challenger's legacy has been to the space agency and to space exploration.
That's a very sobering question for this time of year and this year. And frankly, it's sobering beyond Challenger. This is the time of year when we think about the Apollo 1 crew, lost in 1967, the year that I turned 18 and was a freshman in college and was aiming for a career in the space business. And it's the time of year just 3 years ago where we lost the Columbia crew as well. And I think about all of those folks. I personally knew many of them, not all of them, but this is a time to think about those kinds of losses. And you're right, books have been written about it, and I can't add much. I will say that when I think about it, and I've mentioned this in other fora, there's a book I'm fond of by Ernie Gann, a noted aviation writer, called Fate is the Hunter. And it's a book about the early days of air transport, the creation, in fact, of the the global air transport system, which started in the United States and spread throughout the world. And Ernie flew as initially a co-pilot and then later a commander in that system from its earliest days through the early 1950s, by which time it was pretty well established. And in that book, when you open it up in the modern edition, in the first edition it was in the back of the book, but now it's in the front where I think it ought to be, Ernie has a small salute to the people who didn't make it. Page after page after page of flight crews who didn't make it. As we learned, as flawed human beings, how to go about developing the world's most reliable transportation system of any kind. Today you are, I think, approximately as likely to be struck by lightning and die as you are to die in a crash of a major airliner. But the knowledge that we gained was gained only through many, many, many losses. And I think that that is the perspective with which we have to look at our losses in spaceflight. We are, as fallible and flawed human beings, trying very hard to learn how to do something which is very, very, very difficult to do. Spaceflight is the most technically challenging things nations do. Individual processes, brain surgery or recombinant DNA, may be, in their details, more complex than the execution of spaceflight missions, whether robotic or manned. But when all is taken together, the industrial support base, the civil engineering operations, the flight operations, when you add it all together, okay, only the world's premier nations are able to engage in spaceflight. It is difficult, it is dangerous, and it is expensive, given the technology that we enjoy today. We are learning how to expand that technology into new arenas, and as we do and when we do, spaceflight will become easier. But every single one of us will either have gray hair or will have lost it, as I have, before much of that comes true. It's a tough job, and the losses that we have sustained so far reflect the difficulty of the challenge and our limitations as human beings that we try to push beyond as we try to invent this new technology. So that's what I think about it. The Challenger crew that perished in the wake of that, in the wake of those mistakes. We learned how to design solid rocket boosters that have now executed 178 usages, 2 per shuttle mission, with no further failures. Okay, the solid rocket booster of today has, in my estimation, the best record of any spaceflight component that we currently use. It will be a valuable component as we push out beyond low Earth orbit to return to the moon and to go to Mars. We will be using the solid rocket booster or its derivatives on the heavy lifters that take us to Mars. And we got that from the Challenger crew. So that's part of the learning process. I'm afraid, I know, that in the course of this there will be other opportunities to learn. And they will be sober opportunities surrounded with black crepe. But we will learn in the same way that the nation and the world learned how to do air transport. And it will be difficult. Thank you.
All right, we have time for about one more question.
Well, Bill Harwood again, and I want to ask you a New Horizons question since nobody else did. Can you give us just your perspective on the value of going to the Kuiper Belt, of exploring Pluto, going to a realm that most people on the street have really no sense of in terms of how far away it is or what value it is to learn about it in terms of the evolution of the solar system? So basically anything you want to say about New Horizons.
Well, I would ask, to people who would ask that question, I would ask the question of you, of what value do you think it might be to be able to examine the primordial constituents from which the solar system and all the planets and we ourselves were formed. Because it is believed that the Kuiper Belt contains the remnant objects from the formation of the solar system that never coalesced into planets, or mostly didn't coalesce into planets because they were simply too far out. I can't predict. I'm not smart enough or skilled enough to be able to predict what that value might be. But it is fantastically interesting to me to have a chance, maybe within my lifetime, for scientists to see up close what those objects look like and to begin our reconnaissance of that region of space.
All right. That's going to conclude today's media availability with the administrator and deputy administrator. Thank you all.
position there for a little bit, or this is going to be able to move this out?
welcome you all to this first arrival of our crew. I believe it's the first time that we've had all together for a press conference. So we'd like to thank you for coming. They intend not to thank our crew members for this next mission. That's just one that we want to do. Our commander, Steve Lindsay, is an Air Force colonel. He'll be commanding this mission on the Discovery and taking the 4th space flight with a second as commander. So I'm going to turn it over to you and let you introduce your please.
All right. Well, it's good to be here today. We're down here this weekend for crew equipment interface test, and what that is we're going to crawl around Discovery. We're going to go in the payload bay, take a look at some interfaces, especially our spacewalk and EVA folks are going to do that. We're going to get inside the vehicle, check out the windows, check out some of the switches, do something called checking cable routing, which is all the cabling we use for our photo TV and computer systems. Basically get a good look at the vehicle, some maintenance procedures on the vehicle, and it's our first chance to get up close and personal with Discovery. And so we'll be doing that both today and tomorrow, and then hopefully back for TCDT in a little while here. You guys, probably a lot of you are familiar with the mission, some of you may not. We're going to be a 12-day mission, the second return to flight test mission. We're going to go up and continue some of the repair work that was done on STS-114 and a lot of the inspection work. We have some expanded capabilities we're going to test out. We're also taking a MPLM, same thing that 114 did, up to the space station to resupply the space station, doing 3 spacewalks to support some critical space station assembly, as well as some return to flight test objectives. And we're also have one crew member that's not here today, Thomas Reiter from the European Space Agency, a German astronaut, and we're going to be taking him with us, and we're actually going to leave him up on space station and augment the crew on the space station back up from 2 people that it is now back up to 3 people in full strength. Well, I want to introduce my crew real quick to you, and then we'll take your questions. Next to me is Mark Kelly. He's the pilot of the mission. He's a graduate of the Merchant Marine Academy. He's a commander in the United States Navy fighter pilot, and he'll be going on his second mission. And Mark's, besides doing all the piloting duties, he's also directing the spacewalks from inside the vehicle, so he's been working those with our EVA team, and multiple other jobs. Next to him, Mike Fossum. He'll be Mike's first space flight, graduate at Texas A&M, and he'll be doing spacewalks, all 3 of the spacewalks. He's also riding the flight deck during ascent, and he'll also be directing deorbit preparation activities when we come in the manor. Next to him, Lisa Nowak. She's our flight engineer, MS2. This will be her first flight. She's a graduate in the Naval Academy, also a commander and captain select in the United States Navy. Besides being our flight engineer, she's in the 100 other jobs she has. She's also going to be flying the robotic arm, both the shuttle and the space station robotic arm, and doing robotic operations pretty much every single day that we're on orbit. Next to Lisa is Stephanie Wilson, a graduate of Harvard, and she'll be on her first space flight. Her job, along with Lisa, will also be operating both robotic arms and doing that pretty much every day of the flight. She'll also be on the flight deck for entry, and during ascent and post-insertion, she's responsible for directing the post-insertion activities after we get to orbit. And finally, last but not least, Piers Sellers, graduate of University of Edinburgh. Did I get that right? All right. And yes, I can't talk with the British accent. Sorry. But he's on his second space flight. He's our lead spacewalker EV1. So he's been responsible for developing and directing those spacewalks, in addition to a whole bunch of other jobs, including probably one of the hardest jobs on the shuttle is figuring out how to hook up the 10 or 12 laptop computers we have and getting them all to work throughout the flight and keep them networked. So so that's a quick introduction of a kind of broad brush of what the crew is doing, and I'm real happy to have this crew. They're a great group to work with, a great team, and we have a lot of fun together, and we're really looking forward to getting this mission off soon. So with that, turn it back over to you.
Okay, thank you. I'll take your question. I just would like to remind you that immediately after this, we're going to have all 6 crew members outside. We'll do a quick photo op out there with the back up. So let's go and do it right now. Griffin,
how confident are you that the foam problem on the external tank has been resolved?
It's a good question. The foam problem, obviously we're working on it. Everybody knows what happened on 114. The PAL ramp foam problem, I think we have solved since we've taken the PAL ramp off the tank and it won't be there. So the data that I've seen, I've looked over some of the AIAA reports and the wind tunnel testing on flying without the PAL ramp, and what I've seen so far, I'm pretty confident that that's the right decision, that we're going to be okay with that. We have some more wind tunnel testing coming up in February-March timeframe to further analyze that and make sure we're safe to fly without that PAL ramp. The bipod ramp area where we had another piece come off, I'm pretty confident in that one too. We figured out exactly why that happened and fixed that problem. The program has never advertised that we would never lose any foam, and we will lose foam on this flight just like every other foam. The key is to make sure that the foam that we do lose is small enough size that it can't hurt us if it hits the vehicle, and that's what we're working towards. So I feel pretty confident that the decisions we're making based on the information we have and the engineering analysis and wind tunnel testing, we're going in the right direction. This is a test flight, and part of the purpose of this test flight is to test the changes we've made to the tank. And so obviously we won't know for sure until we fly it, because one of the things we can't do on the ground is we can't put a full-scale space shuttle with external tank and run it in a wind tunnel and take it all the way up to 17,500 miles an hour. We just don't have the facility to do that. The best we can do is take pieces of that, put it in the wind tunnel, and test those pieces, and do the best job we can from an engineering standpoint. So, purpose of flight test is to take it to the flight clearance limit, and that's what we'll do in this flight.
Pat Duggins, WMFE, for Steve. Hi. I was wondering, are you finding yourself asking more questions or different questions? Because the tank for 114 was supposed to be fine, and then all of a sudden there goes the PAL ramp.
You know, the PAL ramp, I think most people have said, is kind of a surprise to us, because we, in the history of the program, you know, we probably had, don't quote me on the exact number, but I want to say 50 or 60 flights in daylight where we saw that PAL ramp. And except in the very, very early, couple of flights very early in the mission, long before I came on the program, we lost some pieces of the PAL ramp, but since that time we haven't lost pieces to the PAL ramp. And then when this happened, it was a surprise because we didn't expect to see that. So the whole program has obviously asked a lot of questions since then. Why did this happen? And I think we finally have a root cause with through this thermal cycling when we took a look at that of the tank and were able to dissect it. So yeah, I've asked questions, but so has everybody else, and everybody's very concerned about it. And I think we're heading toward the right solution. In that, you know, if you don't fly with a PAL ramp, then you don't have the foam coming on. Now the PAL ramp was designed to protect a cable tray, which has since changed shape from the early days, and protects some pressurization lines. And that's what the focus of the testing has been, to make sure we're safe to fly without it. And actually, even prior to 114, there was work ongoing. The plan was to eliminate PAL ramps off the tank eventually, even though we thought they weren't a threat going into 114. So all 114's forced us to do is to accelerate that plan, to get rid of those PAL ramps.
Commander, I understand that one of the pacing items now are the gap fillers that they've identified more that they have to replace. Does this pretty well knock you off of your May window? And also for Commander Nowak, are those naval aviator wings? I'm a little old. I can't see that.
You want to go first? You want me to?
Give me mine first.
Okay.
Mine's an easy question. I'm a naval flight officer, not a pilot.
What was your question again? I'm sorry. Gap fillers. Oh yes. Okay.
Going to be able to get ready for the May window.
I got distracted by the wings question. The gap fillers. You know, in the process of replacing a bunch of them and making sure they're insecure, as everybody knows, we had one come loose and we had to pull it out EVA on the last flight. There's a lot of discussion and debate going on as to, we've got the primary zones done on the gap fillers. There's some more zones that we just signed up to do that also still support May. There's still some debate going on over another section and whether we need to pull those to make May. As far as I know, and I don't have the latest information, I don't think that in particular is threatening the May launch date. There are a lot of, everybody knows there's a lot of work going on to get the tank ready, to get the tank shipped on time, to do a good tank flow here to get us all ready to go. And there's a whole bunch of things out there. Right now we are still holding to May. We are training to May. The program's marching to May, and we'll see. I know, talking to the program managers, that we're trying to make May, but if we don't make May, if the only kind of risk we want to take here is a schedule risk, not a technical risk. So nothing technically is being eliminated for the May launch date. We're doing everything technically that we would normally. If we get to a point where, from a schedule standpoint, it doesn't make May, then we're going to slip. But we're not going to skip any technical steps, and that includes destroying the gap fillers. So that work is ongoing. They're still analyzing, debating how many more gap fillers we have to address before we go fly.
Hey, thank you. Bill? Bill Hurwood with CBS with two questions. One for either Piers or Mike. Could you give us an update on how the TUS IUS task, I guess, part EVA-1 and then EVA-2, how that's shaping up for you? And for Steve, can you, I know there's some recent concern about some contamination, I guess, on an LO2 screen in one of the engines. Do you know anything about that, and can you tell us a little bit about that?
I haven't. Contamination on the LO2 screen? Yeah. You're talking about the catch bottles, or?
No, it's the main engine inlet screen that's got some without frames. Whatever,
Yeah, I haven't heard anything. I haven't heard anything about that. Yeah.
What? You can't do that.
Yeah, Mike, do you want to take the?
Well, we've been doing a lot of work since the failure occurred in December to get the new the TUS and IUA installed on the station. And right now it looks like one of the first tasks that we'll do on EVA-1 is go up to the zenith side of the S0 to go ahead and replace that IUA to allow us to move the mobile transporter down the truss to get it out of the work site for the actual TUS change out. And we'll do that on EVA-2. We've kind of swapped some priorities and swapped some hardware, so we'll be taking the trailing umbilical system up there, and we'll be able to replace that. It's a new task for us. We've run it a few times in the big pool, part of our training. It's kind of tight. It's different. I think we're well on the way to figuring out everything we need to do to get that accomplished.
Okay, Craig?
Craig Cavallo with Aviation Week, and I've got kind of a air and ground management question, lessons learned from 114. Even with some moderate extras that came about during 114, the workload was really exhausting between engineering and flight control. And, you know the whole story, obviously. But in a lessons learned sense, have you found things where you can tune up management and processes a little better from 114 to maybe make things go a little less exhausting if things come up?
Are you talking about in terms of the turning all the data from the inspections, that sort of thing?
Yeah. Plus the fact you had the gap filler EVA, and just, you know, these weren't terribly gravitous things, but they just consumed huge amounts of.
They did. You know, I can talk a little bit about the we have this whole photo processing team that deals with all the inspection data that comes down, and part of the key is turning that data quick enough
to make decisions about the health of the vehicle. And that took more time than we expected, but really it's not surprising given the volume of data. So they've continued to work on that through exercises, and hopefully they'll be able to turn it a little bit faster for us, although they did, honestly, they did a really good job last time turning that. It was a huge management challenge, and they managed it pretty well. In terms of decision-making on the ground with gap filler issues and things like that, you know, the mission management team kind of really reinvented themselves after the Columbia accident, and they did a number of simulations. All we can really do is take the lessons learned from 114 and try to apply them in the future. And so one of the things we've been doing, much like they did, is we actually have been doing some exercises with the mission management team too, where matter of fact, a couple weeks ago we did a long 2-3 day sim. We simulated flight day 2, which is the inspection day, and flight day 3, which is the rendezvous day. And we were given a scenario, and we had the full mission management team playing so that everybody could get training, and they gave us a really difficult case. And everybody got to go through that, going through all the data, figuring out what to do. So the best way we can learn from it is just continue to exercise it, work on our processes, and then at the end of a sim, obviously, do a really good debrief, fold all those lessons learned into the next time, and so everybody can learn from it. So so that's the kind of things we're working on. There's, you know, the gap filler when it happened on 114 was again something that was not expected, and every flight I've been on, there's something unexpected that happens. That's the nature of the business we're in. You know, when we train, we talk about it all the time. You know, that get used to change because change is going to happen, and get used to the unexpected because the unexpected will always happen. And it's a complex mission. It's a complex vehicle. It's a complex and dangerous business. And we can expect change. We can expect things not to go as we plan. So the best thing we can do is be prepared for change and be prepared to deal with the unexpected.
Okay, thank you. Irene?
Irene Klotz with Reuters. To follow on with that for just one point, and then I had a question for Piers. Given that you may have some unexpected time spent on inspections and other things, what is your understanding of what would qualify this mission as a success? What do you need to accomplish to have this be a successful flight? And then for Piers, if you could talk a little bit about where things are with the heat shield repair techniques and what you'll be doing on an EVA this flight.
What would qualify this as a successful flight? I think going up safely, accomplishing our objectives and coming back safely would qualify this as a successful flight. To go further than that, you'd be asking me to specify beforehand, you know, whether everything we try is going to work successfully. And we don't know that. That's why we're a test mission. We hope that it will. We're doing the best engineering job we can to accomplish all those things. And we think we're on the right path. We think we're doing the right things. And I'm pretty confident that the vast majority of our objectives we will accomplish and accomplish successfully. But I also know that there are probably a couple of things out there that won't go as planned, because it's true on every flight. And so for me, a successful flight will be a safe mission where we accomplish our objectives. We get space station augmented. We get space station ready to march on into assembly. And you know, to do that, we need to supply space station, take Thomas up and augment the crew, and we need to fix the trailing umbilical system so that the next mission can do assembly. So those are the big objectives that we're all looking at. You know, we want to leave with a mobile transporter that works, and we want to leave the space station supplied and augmented with a third crew member.
Yeah, about repair techniques. We're doing two things on this mission that are germane to that. First EVA, we're going to get the boom, grab it with a shuttle arm. So you have the shuttle arm about 50 foot long, have the boom about 50 foot long, big stick. And Mike and I are going to stand on the end of that and do a whole lot of evaluations to see if we can use that as a work platform. So if you could reach underneath the shuttle or to the ends of the shuttle and actually use it as a work platform to fix the heat shield. And the other thing we're going to do is on EVA 3 is go down to the back of the payload bay in the shuttle where there's a big box full of samples of RCC coupons, each about this big. And some of them have been mechanically damaged by firing very high velocity projectiles at them. So we've got realistic damage to these coupons. And we're going to attempt some repairs using this special material out there, try and repair about 8 coupons and bring them back for test.
Okay, thank you. David?
David Waters from Central Florida News 13. Okay, first question for the commander. How critical is speeding up the inspection process, since obviously there's been talk in the future of trying to balance actual mission time with time doing inspections? And then the second part, kind of a longer term thing, 4 years till retirement of Shuttle, how many of you are thinking of positioning yourself for being selected for the first moon mission, staying around at NASA for that?
Well, you guys want to address the moon mission first? One of you guys can talk the moon mission.
I don't think, with this flight hopefully a couple months away, I think we're within 90 days now. I think we're all really focused on that. And, to think much further beyond the 12 days we're going to spend in space in May is, we've got too much stuff to do to be worried about what comes next. At least that's my my personal thought about that.
But any of us would like to go.
Yeah, I think that's pretty safe. I think you got 6 volunteers for that. But we don't know when that's going to come, and some people like me might be a little too old to go, I think. But regarding the inspection, we got a lot of assembly missions coming up right after us. The way the inspection is designed right now is we do the vast majority of the inspection all on Flight Day 2. Which is the day prior to rendezvous and docking with the space station, which has always been that way. And all of that inspection does fit into Flight Day 2. It makes for a much busier day than we used to have on Flight Day 2. It's a much more intense day, but 114 got all their inspection done on Flight Day 2. We intend to do the same thing. And then on Flight Day 3, we use the what's it called, the rendezvous pitch. We call it the RPM, rendezvous pitch maneuver, where you do the flip underneath the space station, and the station crew takes digital photography to get all the tiles. And all that happens prior to docking. The analysis is done on the ground, and if nothing is seen, if you don't see any suspect areas, then we're done with inspection. On our flight, we have some time carved out for a focused inspection, much like 114 did, where if we see something, we'll go look at it more carefully. Or if there isn't anything to look at, we'll probably test some other. We have an additional inspection sensor, a digital camera on the end of the boom for us, and we may do some testing with that sensor during that slot of time. So if all goes well on inspection and we don't see anything, the vast majority of it all gets knocked out before we ever dock. So in terms of future flights, they're going to have the capability to do the same thing, go up once they dock, accomplish their missions.
Okay, thank you. We got time for a couple more questions, then we're going to go outside for a quick photo op. Chris?
Chris Kreidler from Florida Today, actually for the first-time flyers. If you could talk about whether you're feeling any special pressure, since this is quite a high-profile mission, you're having fun, just what are you feeling as you're going into this mission?
Just for me, right?
I don't think there's any special pressure. I mean, all of us shared the dream as children, and so we're feel fortunate to be living our childhood dreams. There's a lot of work to do, but we train hard, we work hard. It's a great team, so I think we're all anticipating it. Looking forward to it, but no special pressure there.
I agree with Mike about not being pressured. If anything, Stephanie and I have been here now 10 years and Mike 8, as far as being in the astronaut corps, and we're very ready to go and confident in all the work everybody here and all the teams are doing, and we're looking forward to having a great mission.
And the same for me, no special pressure. It's been great training with this crew and working with all the people that support us, and we're looking forward to executing our mission.
Peter?
Good morning, Peter King with CBS News Radio. And the question's for Piers, since you were talking about the heat shield repair technique. We haven't heard a whole lot about the results that came from 114, and I'm wondering what happened with the 114 samples, what we've learned from those, and particularly things that might help you during your EVA.
Yeah, we learned quite a lot from 114's very brief opportunity to go out and do a preliminary test of these materials. They did two things. One was the mitten wash test, where they practiced on a piece of broken tile, putting this gray material that sorts out the emittance of fractured tile, and that worked out very well. The stuff adhered, performed nicely. And then they went off to try putting this NOAX material, which is this black goop, to repair RCC cracks. And their only opportunity to do that was under very, very cold conditions in the experiment box. So they put it on there and then closed up the box. And as it happened, because of the very cold conditions, the stuff didn't really dry out before they had a chance to completely work it into the surface. So there's quite a lot of voids, bubbles in that sample. And that's sort of what we expect from the tests we've done on the ground. They were kind of unlucky that the only shot they got at it was during very cold conditions. So given what we've learned from the chamber runs, given what we've learned from 114's experience, our team has worked out a schedule so that we're going to try this under optimal conditions. Very warm surface, warm material, put it on, all the bubbles should come out, and you should get a good fix.
And are you going to get more time than the 114 crew had? Because I think they only had about an hour to work on all
Absolutely.
this.
We're dedicating the whole of EVA 3 to this, so we expect to give this a really good trial. That's the goal.
Okay, we'll squeeze in one more question. Dan?
And Dan Pillow from Channel 2. I'd like to address this to anyone. As astronauts, obviously your job is to fly in space. You were hoping you'd fly last year. Now it might be next summer. Just tell me, how is that? What do you think of that as astronauts who hardly ever fly?
Who wants to take that? Well, it's it's frustrating to see delays in the program, but obviously we want to fly as safely as possible. Having said that, it's still really good to be at the front of the line instead of the back of the line, where we'll be as soon as we land from this flight. And the one thing I'd say is I've been in the office 11 years, and I've had a real good run. But if you think about it, we spend the vast majority of our time supporting other flights, not flying ourselves. And that's folks that come into the office come in with that understanding, and you can get just as much satisfaction out of supporting other flights and working as the team and helping out with these other flights, whether it be space station, space shuttle, or working on the next generation vehicle, which a lot of us are doing now. And that's really the majority of our job. The flying is a perk, it's a bonus, it's a great thing to do. Everybody looks forward to it, but it's not about us flying the flight. It's not, you have some individual goals, but it's really about a team effort and seeing that all the flights go off as successfully as possible. So, and that's probably as rewarding, if not more rewarding, than flying yourself. And that's been my experience after 11 years in the office.
Okay, sir, that's all the time we have for questions, so we'll close this out right now. Thank you very much.
All right.
And,
Good afternoon, and thank you for joining us today for the Space Shuttle Program Update. We are joined here today by Wayne Hale, Space Shuttle Program Manager to my left, Mike Leinbach, NASA Launch Director, and Tim Wilson, the STS-114 External Tank Tiger Team Lead with the NASA Engineering and Safety Center. We will begin with a few comments from the participants, and then we will move on to questions. Wayne?
Thank you, Jessica. It is great to be here in Florida today. We got a report this morning the external tank barge is just off Key West and is going to arrive here tomorrow. We're very excited about that. As you know, folks all around the Space Shuttle program have been working very, very, very hard to get to this point. We have a considerable amount of work ahead of us. I want to tell you a little bit about what we've been doing and what we're going to do. I have a little video, and if we could get that to roll, we'll talk about what we're looking at. We started with some video in the orbiter processing facility. As you know, one of the real challenges we had on STS-114 was a gap filler that came out from between a couple of tiles that caused us some concern. There are about 15,800 gap fillers on each orbiter, and we've made a commitment before the first flight of each orbiter. We're going to change out at least 4,000. They're just about finished with that work on Discovery and getting ready to start work on Atlantis and then Endeavour. This picture shows the boom sensor system that we use for inspection being lowered into Discovery's payload bay, the yellow strong back holding that boom on. This is the STS-121 crew down for the crew equipment interface test about a week and a half ago. They inspected the payload bay, looked at all of the equipment that they might use on spacewalks, all the crew equipment that's stowed in the mid-deck, and became familiar with the particular configuration of the orbiter. Here they're looking at the sensor suite on the end of the orbiter boom sensor system, 2 lasers and a newly improved digital camera, which we'll be flying for the first time on STS-121. Here we have some shots of the engine installation. It's always a good day when you can install the engines in an orbiter. It says you're getting ready to go. We've had some challenges with engine installation this time. We've been working on some seal problems. We think we've got a good configuration. There's still a little bit of engineering work to prove that, but all 3 engines are in Discovery and ready for flight, we believe. Here's the crew at Michoud Assembly Facility outside New Orleans last Thursday. While we were having a big management review, they went out to see the hardware. This is their tank, ET-119, which we shipped. You can see the pilot there looking at the area where the PAL ramp was removed. That light-colored area is where the foam ramp was removed. The very white little toes on what we call ice-frost ramps have been resprayed. You can see some of the protective equipment that is new at Michoud so that the workers can work on areas of the tank without physically touching or leaning on the tank. You can see the gray cable tray that we've talked about and talk about some more today, along with the 2 pressurization lines that run up the side of the tank, and then the big 17-inch liquid oxygen line in the foam insulation up at the top. This is a test for one of the areas that we found a problem with during the STS-114 flight. We had some liquid air condense and travel down the wiring that led to heaters in the bipod area. These are the wires. We've developed a new technique that injects a sealant inside the wires so that no air can travel actually down inside the insulation. And then in this test article, you can see the technician's training to seal the wires on the outside so that there is no gap between the outside of the wire and the foam insulation. This is all our attempt to mitigate any liquid air that might form, which could be underneath the foam and cause foam to pop off during flight. So you can see this is delicate work. And here we are last Friday. I was pleased to be again in New Orleans for the rollout of external tank number 119, which will be our flight tank for the next shuttle flight. The workforce there is really proud of what they've done. You know, I have to say my hat is off to them. I get a lump in my throat when I go down there. We drove through the Gentilly area on East New Orleans, which is still devastated. And the folks that built this magnificent piece of precision spaceflight hardware are having to deal with just a huge personal catastrophe in their community and in their lives, living in really, I think, incredible circumstances or commuting long distances, and the fact that they can and do come to work every day and have done such incredibly precise and incredibly sophisticated work and turn out the spaceflight hardware which meets every test is just a real testament to them. As I was standing there at Building 420, the final assembly building at Michoud, I kept remembering the words of William Faulkner when he said, "I believe that man will not merely endure but will prevail." And I think that is probably the tribute that I would say that I've gotten from the folks that have done this work. I'm inspired by what they're doing. I wanted to talk a little bit more about the external tank. We have 3 slides which I'm going to show, which came from our management review last Thursday when we assessed the readiness to ship the tank. and I've asked that these be put up. So if we could put up the first slide, we'll give you hard copies of this. I know it's a little hard to read on the TV, but we had a number of areas where we have done additional work to mitigate the debris of foam coming off the external tank. We have looked at these in particular 6 or 7 areas. I talked a little bit on the right, the bipod fitting, the wires. You saw that the work we're doing there. We've done more work in many areas, and I'm going to talk about several of those in detail, in particular the 2 on the bottom. On the right, as you know, we have eliminated what we call the PAL ramp, the protuberance air load ramp, which was about a 35, 37 pound 2 pieces of foam that we have eliminated off the tank. That is an engineering challenge to prove that the aerodynamics are still good on the tank, which is still in work, but we believe that eliminating that foam off the tank was critical to providing a safe flight vehicle. So that is, as you saw in the pictures from the shoe, is off the tank. Having eliminated that large piece of foam, we turned our attention to the next largest area piece of foam that we think we might have some reason to be able to eliminate parts, and that's on the lower left. We call those ice frost ramps. And if we could go to the next page, I think there's an even better picture. Down the side of the tank, we have the 2 pressurization lines for the hydrogen and oxygen tanks, bringing hot gas, or I should say warm gas, off the main engines to keep the oxygen and hydrogen tanks pressurized, and also the gray square cable tray that carries all the instrumentation wiring from the bottom to the top of the tank. Those structures are on the outside of the tank. They are metal structures. They're clamped with metal clamps to the aluminum skin of the tank. And as you would imagine, it conducts heat quite well. And so to keep the ice from forming on those structures, they're covered by foam. In this particular instance, we call those the ice frost ramps. There's 15 of them down the side of the hydrogen tank, as well as several up on the oxygen tank. And as you can see in one particular location, what we call X Station 1334, because there is a flange in the pressurization line, we have less foam. And in our post-flight analysis of the photography from the tanks, we found that this area in particular had less problems with foam coming off around the ice frost ramp than other areas. This plus the information that we've gotten from the ET number 120 that we had at the Kennedy Space Center and tanked and sent back to Michoud for investigation, shows that cracks can form under this thicker foam. And so we are today, in fact, we had another series of meetings to look at how much foam we can remove in this area. Again, we took the PAL ramps off, which was about 37 pounds of foam. Each one of these ramps is 1.5 pounds to 2 pounds of foam. We cannot fly without insulation because ice would form on the brackets as they are connected to the cryogenic tank, which is very cold. But we do believe that reduction in the amount of foam there would reduce our risk, and that in fact is work ahead of us. The last slide I wanted to show you was what we think is going to happen during the next flight. Just to make it perfectly clear to you, foam will still come off the tank after we have done all these mitigation efforts. What we have done is worked off all the large pieces, and we believe that pieces that come off will be small. And as you can see, we've got a little graphic here that shows what we believe we'll see come off the tank before solid rocket motor separation at about 2 minutes, and what we believe will come off and be seen after solid rocket booster separation from about 2 minutes until we separate the tank and take the photography. And we've rated the likelihood of what we will see from the most likely to the least likely, and our task ahead of us is to ensure that all of these very small pieces of foam, most of them less than an ounce, will be of a size that they cannot have enough energy to do damage if they strike the orbiter. So that is work ahead of us, and I wanted to make very sure that everyone understands that we are trying to eliminate critical foam loss, but we will expect to see foam coming off this next tank. And as we go forward in the manifest for the next several flights, we'll continue to make improvements so that we can eliminate even smaller and smaller pieces of foam loss as we go forward. There's probably quite a bit more I could say, but I'll leave it at that. I've taken enough time, and I'm going to let Mike Rembach talk and Tim Wilson, and then we'll take your questions. So, Mike?
Okay, thanks, Wayne. Well, folks, it's really good to be here today. It must mean we're getting closer to a launch count, and the whole team here at Kennedy Space Center feels really good about that. The external tank, as Wayne reported, has made the turn around southern Florida and should be in Port Canaveral tomorrow about noontime. And weather permitting, which it looks like it will, the tank will be up in the turn basin just outside here tomorrow afternoon, early evening, hopefully before dark. You'll be able to see the tank tomorrow afternoon. The team here at KSC is very focused on what we do. We're anxious to get the tank here. The two solid rocket boosters are fully mated, and we're going through the closeouts now, so the boosters are going to be ready for the tank after it goes through its standalone processing in the vehicle assembly building. So in general, we're just really glad to get another piece of flight hardware here, and it'll be one more step closer to the launch. And so speaking on behalf of the Kennedy Space Center workforce, I'm proud to do so, and we're ready to receive the tank and get on with mission processing. Tim?
Well, I'm Tim Wilson, the NASA Engineering Safety Center. I'm leading a team that was tasked originally back in August with taking an independent look at the program's efforts to resolve the 114 foam loss issues and ensure that those were done with proper technical rigor. Our team originally released its initial report, back in October. We've been following the progress that the program has made in resolving those issues through the tests and the analysis that have been underway. We've been reestablished now as we get closer to launch here to take another look at the work that the program's done, measure their progress against some recommendations that we initially made, and ensure that those have been properly implemented. So we'll be working along with folks in the program to ensure that that work is done with, like I said, with good technical rigor, and that the issues are properly put to bed before we fly again.
Thank you. We will now take questions. As always, please state your name and affiliation, and we will start on this side of the room and work our way over. Tom?
Tom Costello with NBC for Wayne. You talked about that's close. You talked about how you hope that every piece was an ounce or less. What would be the physical size of it? I understand the weight, but what are you thinking in terms of physical size? And I realized that the fatal wound that was inflicted on the crew 3 years ago was in fact roughly the size of a briefcase. I mean, what physical size do you think you can withstand? I realize you don't want anything to hit it, but what can you withstand?
Well, again, we talk more in terms of mass, which goes to kinetic energy, than we do for size, but this is definitely smaller than a matchbox kind of size piece of foam that we would like to stay beneath. As you know, the piece that was that led to the Columbia accident was a little less than 2-pound piece of foam. The piece that came off the STS-114 PAL ramp was just over a pound piece of foam. Those rather large pieces of foam clearly are not acceptable, and it has been our goal to get rid of any foam that might come off in large sizes. As you get to small pieces, then clearly we have what we call popcorn, which has come off, which is about the size of a pencil eraser, and we've seen that for years. That clearly does not pose a threat to us. So as we eliminate the large debris losses and get down to the very small pieces, we think we will have eliminated the threat.
Craig?
Craig Devault, Aviation Week. Wayne addressed the tiny particles in the main engine system screens, and is there a rationale to proceed if you don't know exactly what those materials are?
Good question, Craig. You know, we have a number of other challenges, as we always do. Anytime we get ready to bring the shuttle to flight, it's been my observation for the past 20 years, there's always half a dozen to 20 different issues that need to be reviewed in depth. And clearly, any particles on the pre-valve screen are something that we've been interested in. I got a printout from the folks of all the pre-valve particles we've seen over the last 15 or so years since about STS-26, and that ran to about 30 pages of 0.6 font write-ups. So there have been a number of particles over the years. Now, the concern is twofold. One is that you have a piece that's large enough to get down in the engine and actually stop up something that's vital in the engine. The pieces that we're looking at right now, and there's one in Discovery and one in Endeavor that have our current attention, are clearly small enough that we're not worried about that. We've cleared it from the plugging up of coolant lines or small ports in the engine, so that's not a problem. The question that remains is, are they an ignition source? When you are in a pure oxygen environment, we're talking the liquid oxygen line, things that would not normally be a combustion hazard can be a combustion hazard. We've had a number of incidents in the space program over the years of oxygen fires, and we're very sensitive to that. So this very small particle that we see lodged in pre-valve screen, if it is certain kinds of metal, could be an ignition source. And we've been running some tests out at the White Sands Test Facility, where they are the world's leader in understanding oxygen systems and impurities in oxygen systems to understand what kind of a threat. We're talking about something that if you broke off the pencil lead on your mechanical pencil, just the little end of it is about that size piece of material. If we determine that it's a threat, we will go in and remove the cover and clean the screen. We haven't reached that conclusion yet, and based on previous cases that we've had, we're hopeful that we can clear it. Right now, we think that the only material that it could be, and because we can't get it out, you can't tell what it is titanium, and we don't have any titanium in an oxygen system because titanium is flammable in oxygen. It would be some other kind of metal, aluminum, steel. Those would not be flammable and they would not be a hazard. So we're running a few more tests on the system, and we'll decide what our risk is to fly with this very small particle in place, or to take it out and clean the screens. You know, cleaning the screens sounds simple, but it's never simple. And the fact of the matter is that you run the risk of introducing more contamination when you take the covers off and clean the screens. So it's another one of those very interesting decisions we get into in the space flight from time to time. We want to be safe. We want to make sure that we've done all the engineering and all the tests that we can do to assure ourselves that it's safe. And at the end of the day, it may very well be a judgment call on whether we go after this particle or whether we accept the risk that it's something that shouldn't be in there in the first place and fly with it as it is.
Griffin.
Thank you, Stephen Gordon for Time Magazine. Mr. Hill, are you finished with all the wind tunnel tests on the power lamp area and done, and you're sure that everything is fine?
Well, you know, that's a very interesting question, Stefano, and the short answer is no. In fact, I would tell you that we have just started. We have a number of wind tunnel tests that are taking place in a number of different high-speed wind tunnels around the nation, at the Glenn Research Center, at the Ames Research Center, and at the Arnold Engineering Center in Tullahoma, Tennessee. To gather the data that we need, it takes a fair amount of time to build the models up, these precise wind tunnel models. That really is kind of the lead time, and then get them into the tunnel and get the data that you need. What we have done is computer simulations, and the computer simulation and the paper analysis indicates that the structure should be able to take the aerodynamic loads that we generate on the cable tray, in particular after we remove the power lamp. But the proof is in the wind tunnel testing. We've got a series of wind tunnel tests. The first kicks off in just a couple of weeks at the Glenn Research Center. And we hope to get the data that will confirm that our rather conservative, what we hope is conservative engineering analysis on paper will be borne out and will be good to fly. If we find a surprise in the wind tunnel, well, that's good news because you want to find it out in the wind tunnel and not on the flight vehicle, then we will go deal with that, and that might mean any number of things up to and including the changing of some brackets. So that work is ahead of us, and frankly that will be, when we look forward to the launch date, which I'm kind of surprised I haven't been asked about. Yeah, hands are going up all over. When we look forward to the launch date, the thing that is going to pace getting Discovery off the ground is not the work that we're doing at the Kennedy Space Center, because we believe that we have that well in hand and know what to do. But it is the engineering analysis and tests that go toward proving that what we have assembled on the launch pad is safe to fly. And in fact, those wind tunnel tests and that analysis is one of the key pacing items that I review on a weekly basis with the team to understand how we're doing.
Pat, and then we'll go up to Mike.
Pat Duggins, WMFE, and since one of my colleagues will be happy to ask you about the launch date, I would be more than pleased to defer to them on that. I was wondering, and anybody can address this really, the concern about engineers second-guessing themselves, because when you sent up 114, the tank was judged safe, there goes the power ramp, now we've got another mission coming up. Any concern at all that people are going to be looking at things that they think are safe, but then they're kind of wondering in the back of their minds, well, maybe they're not?
Well, you know, one of the things that we pay our large engineering staff and our large safety staff to do are to worry about the imponderables and the unknowns, and to make sure that we have the rationale that we need to have done the right tests and have done the right analysis to make sure that we're safe to fly. Frankly, in the post-Columbia time frame, we all knew that foam was a problem. We did a large series of ground tests, subscale tests, piece part tests, over 500, I believe it was, tests, and very, I would say, expensive facilities. I mean, thermal vacuum chambers and high-speed wind tunnels, trying to understand why foam came off. And we came to some conclusions about why the foam is not staying on the tanks. On 114, we found a phenomenon that apparently only occurs on the full-size tank, which we only found because we had a full-size tank that we ran out to the launch pad, tanked up, took back to the factory, and cut the foam apart. That is a new phenomenon. That's a new failure mechanism, if you will. We think that, in retrospect, I wish we had done this test, you know, in 2003, but it's good to know now. And we think that we have, to a reasonable extent now, all the failure mechanisms understood to a first level, and our goal is how do we apply foam or remove foam in some cases to ensure that we don't lose any pieces from any failure mechanism. But people are continually asking, not just about the foam, but about all the parts of the shuttle. Are we safe to fly? Is there any new information out there that we should consider that says that we need to stop and maybe do some additional work to ensure that we're safe to fly?
Mike?
In the latest version of the implementation plan for return to flight, the report said there were 16 pieces of foam that fell off Discovery. I was wondering if you all set any goals on how much you would like to reduce that, and then also, do you know of those 16 pieces, did any of them strike the orbiter?
You know, we did very thorough, I think, photographic analysis. We also had sensors in the wing leading edge to see if there were any indications. There are some marginal indications that perhaps some of the small pieces did in fact strike the orbiter, but we don't have what I would call solid evidence. None of the wing leading edge sensors gave us a value of a hit, if you want to call it that was much above the noise threshold, for example. The video from the external tank camera, while very interesting, wasn't conclusive in that some of the particles appeared to go close to the wing, but whether or not they struck, we don't know. It does not seem to correlate with damage that we saw to the tiles, for example. So we did lose several small pieces of foam and one large one. We clearly know the large one missed us, which is good. We're trying to prevent the large pieces from coming off, and the small ones we think we can control to a level where they wouldn't cause damage if they did strike us, and it's possible they did on 114.
Mike, and then Bill and Irene.
Mike Evans with the Orlando Center for Wind. Talk a little about the engineering analysis. Last year that was a long, complex process, and in fact it moved the launch date to the right, I guess. You've got a limited amount of time, obviously, to get this done before your May window. What is the timing of this? What do you foresee it as being? Is this going to be something that's going to go right down to the wire? And I'll ask the launch question. How optimistic are you that you can get all that work done in time to fly in May?
Well, my observation, Michael, is that the engineering always goes right down to the wire because given more time, the engineers will work on it more. So they will try to refine their analysis and run additional tests, and no matter what schedule or deadline you put out there, they will complain that it's not long enough to get done everything that they would like to do. That's part of the art of managing, I think, one of these highly technical systems is trying to figure out when you have done enough and when you have reached sufficient rationale. It's very difficult to prove anything conclusively in life. You try to come to a reasonable level of understanding. And look at what the standards and the practices are in the field. We will run right down to the wire, whatever the launch date turns out to be. Right now, I have asked, we put in, as I think several of you noted, a request for the team to evaluate a May 10th launch date. We're going to review that, the results, the response, if you will, to that review on Thursday. I expect, and already have been given some hints, that there are going to be some poke outs, and I'm anxious to see, the question is not are there poke outs, the question is how many, and can we mitigate them by having more engineering staff assigned, or perhaps by looking at the exact tests and analysis that need to be done and seeing whether we really need to do all of it or not. So we're going to have a very interesting discussion Thursday. Now, before you go off and ask me, are we going to announce a launch date Thursday? No, we're not. That'll be another step along the process to look how we're progressing. Right now, the workforce, as Mike Weinbach will tell you, is working toward a May launch. We think the Kennedy Space Center work, the processing work on discovery, the stacking of the solids, the assembling of the tank, rolling out to the launch pad. We think all of that with I don't know how you want to characterize it, but with a somewhat aggressive schedule can occur and lead to a launch before the launch window closes in May. That's not the real tough question. The real tough question is, will we come to a reasonable consensus that we have done enough to mitigate foam loss once again? And there are, as I said, probably a dozen other issues that we're looking at on a daily basis to see how we're coming to resolve them, because any one of those could turn out to be a speed bump. But as of today, I see no reason to say anything other than we're progressing toward May. I remain optimistic. There is a lot of work to be done. I will commit to you and to the team and to the crew that we won't proceed until we have done the work that we need to do to prove it's safe to fly. When I was the entry flight director, I used to come over to the press conferences, and everybody would ask me, well, Wayne, what's the weather going to be like tomorrow? Are we going to land in Florida or California? And I would always say, well, we got to wait and see what the weather is going to be when we get there. And I would tell you this is very similar. We got to wait and see how the engineering work comes out, and when we get some of the answers, we will or we'll delay until we get where we need to be.
Bill Harwood, CBS. Two quick questions. One, just to follow up Craig's. If you have to remove that FOD from that inlet screen, that does May, right? I mean, you can't make May if you have to actually go do that, is one question for you. Second one, is 116 going to go to Discovery? I mean, I'm hearing you're going to go Discovery Atlantis. How does that stand? And for Mike, if the tank shows up tomorrow, I guess, if that CR goes through for May 10 or somewhere thereabouts, I mean, you're a 62-day flow. You guys don't have much contingency time, if any, do you? I mean, how much post-shipment work is required on the tank right now? And how much time do you have in your schedule for whatever date, I mean, ultimately comes up in the May window? What's left of it?
Okay, I'll let you start.
Okay, I'll take the second part first. Part of good program management is for all the projects to give Wayne some contingency in his schedule to get to a launch date. We've historically always done that. The external tanks typically show up where they are not in the critical path for a launch. In fact, they're well outside the critical path for launch. That's not the case this time. This time when the tank shows up, it is in the critical path to get to a May launch attempt. And in the spirit of providing contingency in the past, we used to provide on the order of 25, 30 days of contingency. And the whole processing flow from the tank through the SRBs, the orbiter processing, and the vertical flow out the launch pad. What we have done this time, and been quite upfront with Wayne and the rest of the program elements, is we've put together a schedule that has no contingency in it. It has also not taken out any of the required work. We're going to do everything on the tank and the boosters and the orbiter and all the tests out the launch pad that we do for every flow. We have just not scheduled in any contingency time. And so that, some people could call that an aggressive schedule. I like to call it an exciting schedule. It has a reasonable chance of success. If we run into a significant technical issue, we don't have much time to resolve it, obviously. But barring the big gotcha in the processing, we feel pretty good about making that schedule. The team, I wish you could go out and talk to the team who processes the tank and the orbiter. They are truly excited about getting this next piece of flight hardware here. And if anybody can pull this off, it's the outstanding team here at the Kennedy Space Center. That said, again, if we run into a big gotcha, we don't have much time to resolve it. We've taken a fairly significant mitigation step to that end and reconstituted the Return to Flight Action Center, which you may recall we put in place here at the Kennedy Space Center before STS-114. And it has senior managers, senior technical managers from all the different disciplines across the program that would be able to address that big gotcha, or even small ones as they come up in the processing flow, so that the disposition to problems as we pick them up, because we know we will, so that those dispositions will occur as quickly as possible. So we've assembled all the right people here at KSC. They're on site now, and as problems crop up, they will address them here real time, as opposed to waiting for the email correspondence back to the various space centers and the design centers, etc. They're all here, ready to jump on a problem. So that should help. That will help. Again, there's no contingency to get to that early May launch date, mid-May launch date, but I personally feel very good about the schedule. We've never done it this way before, and we'll see how we do. And I obviously wouldn't recommend doing a no contingency schedule every flow. That doesn't make sense from a project management perspective. But for this time, given where we are in the program, it makes sense to make a run at it. And again, the team is super excited about making that run. So I personally feel pretty good about it.
Mike, do you have the information on the pre-valve screen cleaning? I don't have that right in front of me.
The pre-valve screen cleaning, we've tried to remove that particle out of Discovery. There are test ports in the main propulsion system where you can put in a bore scope, and some bore scopes have essentially little tweezers on the end type of arrangement. We've tried to get that piece out. We can't get it out. So to open up the system and clean the screen is an extensive job. It still fits the processing flow, but it's an extensive job, one that we don't want to do. But if the program decides it's a risk to flight, then obviously we will do it. Again, another issue with that is what Wayne addressed earlier, is the collateral damage when you're breaking into a major system like that is an extremely clean system. You might do damage to seals, you might ding this, collateral damage, and also introducing other FOD into the system is a major concern. So you have to weigh the two. But if we were directed to go pull that piece out, we'll go get it. And right now, we could still get that done before the orbiter rolls out of the OPF.
Well, I'd like to address the last part of that, because if we decide we need to go after that particle, which is the point of the testing we're doing, then it doesn't matter whether it affects May or not. We'll go do what we need to do, and the schedule will be then whatever the schedule falls out to. So it's a technical decision. If it's not safe, we won't fly it. To your question about the STS-116 flight, which is 3 flights down, originally slated for Endeavour, for when Endeavour comes out of its heavy depot maintenance. We have pulled a number of resources off Endeavour, particularly in the tile area, thermal protection system area, to work gap filler. So it looks like we're slipping on the capability of Endeavour to support that mission. So we're evaluating the option of moving that particular cargo manifest to Discovery. And that's normal work in the program. We've traded around which orbiter does what mission all the time based on when they come out of depot maintenance. Clearly, we'd like to get the gap filler issues behind us. I would really like to have the TPS team installing those BRE-18 tiles that are resistant to impact rather than working on gap fillers, but we've got to do the gap filler first. And we've got to do the gap fillers on all the vehicles before they fly, at least the ones in the critical area, about a quarter of the total number of gap fillers on the vehicle. So we're continuing to monitor that workforce. And that workforce is really the most stressed, if I could use that word. It may be too strong a word, but they certainly are one of the few that we've been working to the maximum overtime ground rules at the Kennedy Space Center to get all that work done.
Irene and then Todd, and then we're going to go to headquarters for questions.
Thanks. Irene Potts with Reuters. For Wayne, that obviously your primary concern is for the crews and the ships. From a bigger perspective, can you address a little bit what's at stake for the shuttle program if the foam issue is not resolved with 121, or if it reappears on the subsequent flight in light of shuttle retirement and CEV starting up and the budget issues?
Well, the nation, the national leadership, has given the shuttle program the assignment to complete the International Space Station by the end of fiscal year 2010. And it's something that we take very seriously. That is our job. And clearly you can't have many more big, long stand-downs and accomplish the number of flights that it's going to take to assemble the International Space Station by that date. And so our goal is to try to eliminate the problem as soon as we can. We could have just taken the power amp off and said that's good enough, and we'll fly all these ice frost ramps and these other 4 or 5 areas as is. And some people have argued we should only make one change at a time, in the sense that some of these are fairly complicated, and how they play together makes it even more interesting to analyze. But if we did that and had some significant pieces come off, we would really be sorry about it. So we're trying to do everything we can to get as much eliminated as we can on this next flight. I'm not telling you that we will never have another surprise. I would be foolish to tell you that. Our goal is to try to take care of everything that we know about.
Todd?
Todd Halverson of Florida Today, one for Wayne and one for Mike. Wayne, could you discuss the manifest going forward toward the end of the year? We're hearing that you may have 3 flights that you're planning, and I'm wondering if you can give us time frames. And for Mike, I was wondering if you could give us an idea about the processing of Atlantis in terms of rescue mission capability and its ability to support the manifest in that regard.
I remain very optimistic that if we can fly in May or July, that we'll get 3 shuttle flights off in this calendar year. It does depend on what happened to those flights, because when we get back from the mission, we have to review what happened and see if there's anything that affects the next flight. We have been holding a series of management meetings to make sure that we have the right resources staged to be able to look at any in-flight anomalies and come to a resolution on them in the about 10 or so weeks that we'd have between flights. That is going to be a challenge to change from this kind of interregnum period where we've had lots and lots of time to work on anything and everything to the maximum extent possible, down to something that says, well, we need to kind of turn the crank here and do what is reasonable and proper, surely, but probably not gild the lily. So we are really trying to look at where that happy medium is and prepare the workforce to be ready to do those kinds of things. So I remain optimistic that if we fly this summer, we'll be able to get 3 flights off this calendar year, and but time will tell. This is not like the railroad. Well, maybe that's not a good example. I was going to say airline, but that's not a good example either. We have a manifest, and we are going to achieve the goals of the manifest, but whether we fly, this Thursday or next Saturday in the bigger scheme of things is not what it's all about. You've got to fly every flight safely and accomplish the goals that you set out to do. You know, this next flight, I probably was remiss in saying this, has changed in a profound way. STS-121 was going to be our second test flight in a logistics and resupply mission for the International Space Station. Because of the failure of the trailing umbilical system, they are frankly crippled in their robotic operations today on the International Space Station, and we have a vital new task that we've got to perform on STS-121 to re-enable the robotic systems on board the International Space Station so that they can support the next assembly flights. And quite frankly, that's as much in the critical path, doing that work, getting that payload on board, making sure it's safe, training the crew, making sure we got all the spacewalking procedures to do that work. That's as much in the critical path as anything we're doing. And Mike, you had a question, but I've forgotten what it was.
Sure, it's Atlantis and the capability to support the rescue mission if necessary. The short answer is Atlantis is in great shape. And as long as we stay on track for her launch date that we're assessing, which is late August, that also supports the rescue mission capability should we need that. So right now Atlantis is in good shape, no issues there.
We have not established a requirement for rescue capability. I've asked the team to look at whether or not that would be feasible for us to do. I think the goal that many of us have held for a long time is we would like to have the International Space Station at a place where its life support systems were robust enough to just in the normal course of flying shuttle flights have enough stay capability that the next flight in the normal flight preparation flow could serve as a rescue flight. That's the goal that we'd like to get to long term, and we're evaluating the capability of doing that on having a rescue capability on STS-115.
We will now go to NASA headquarters for further questions.
Guy Gugliotto from the Washington Post for Wayne. Now that you're going to take off the power ramp, you're going to lose, I guess, 39 pounds of foam and probably lose some additional foam on the other fixtures there. Is there a possibility that you could have issues regarding the symmetry of the tank and that you would have to balance it in a different way?
Well, let's see, Guy. Regarding the symmetry of the tank, that goes to the flight control, and in fact we don't believe that we're going to have any flight control issues, but that obviously is one of the things that is going to be checked in the wind tunnel testing. The principal area of concern in removing all that foam is to ensure that the shock waves that set up in a local area around those fittings that I showed you in the earlier pictures don't have any undesirable side effects. The state-of-the-art in aerodynamics is such that you really still need to do that unsteady or transient supersonic shock wave work in a wind tunnel. We can do great things with computational fluid dynamics, but the transient or unsteady, as they call it, aerodynamic forces are what we need to really look at hard in the wind tunnel, and then the structural dynamicist can take those results and make sure that the structure is strong enough to hold up under those extreme forces.
Warren Larry, New York Times for Wayne. A couple of things. One on the engineering test data, the wind tunnel data. Can you get all of that done before a May launch date, or will you have to make your wind tunnel decisions based on preliminary data without a full analysis? And secondarily, on the main propulsion system and the seals you have, which are not quite spec, how comfortable are you with that? And have you guys ordered a whole new set of seals that are spec for future flights?
Well, let me take on the seal question. Yes, we have ordered a whole new set of seals. These are not, go down to the auto parts, kind of buy a seal off the shelf kind of thing. They're 8-inch diameter pipe, And when you're talking about a cryogenic fluid, liquid oxygen or liquid hydrogen, they're made in very precise ways. We have been having a problem with the seals being undersized for a variety of reasons that are not readily understood. We wound up with a number of seals that were not as thick as they should be, and therefore they had some problems with leakage. We've got a good set of seals in the ship now in the sense that we've passed leak check, but the seals are somewhat by a few thousandths undersized, and we have got an engineering analysis team taking a look at whether that is acceptable. And when I say undersized, they're undersized in thickness from what the original design engineers wanted. In the meantime, we have ordered a new batch of seals from the manufacturer. We expect to get those in the next couple of weeks. And if we come to the conclusion that the current seals that are installed are unacceptable, we can change those seals out without completely removing the engines, and even in the vertical. So we think that issue will be resolved in due course. Going back to your wind tunnel testing, we have a whole series of wind tunnel tests. What we've done, I'll try one more time, we have done an engineering analysis, which when engineers do analysis and they don't know all the inputs, they make some conservative assumptions in the terms. And we have got that engineering analysis, what we call the preliminary design review, or PDR, aerodynamic environment, has been handed off to the structural engineers to evaluate whether or not those pipes and cable tray can stay on the outside of the vehicle without the protuberance airload foam ramp. We believe that analysis was conservative. In other words, we believe we've overestimated the forces. But we need to go into the wind tunnel to prove that. So we have got actually 3 different models going in 3 different wind tunnels with increasingly higher levels of sophistication to make sure that we understand what's going on. The first set of models goes in the Glen tunnels in just a couple of weeks. Then we have another set of models that are going in the Ames tunnel shortly after that, and we have a third set of models going in the AEDC tunnels, which run out into June. So the answer is, if we are confirmed in these early wind tunnel tests that our results are in fact conservative, then we are in good shape. If we find some results we don't like, we'll have to go to the next series of wind tunnel tests and see what they yield, and it may in fact take us to the 3rd set of wind tunnel tests. So we will only fly if we have again achieved a reasonable level of understanding that we have the aerodynamic forces well enough understood and the structural analysis completed to the level at which we believe it's safe to fly. You know, we started this out by saying we wanted to fly at least 2 tanks, not in the wind tunnel, but in actual flight, that were heavily instrumented with the PAL ramp on. We then found cracks in the PAL ramp foam that indicated that was an unacceptable thing to do. Clearly, from gathering the aerodynamic data, that was the best thing to do. So when you go look at these kind of tests, it's always a compromise. When have you got the data you need, and how much is enough?
We will now go to the Johnson Space Center in Houston for questions.
Mark Carreau, Houston Chronicle. I have a question and a follow-up. I'd like to follow on that last question first. In fact, are you looking for the appliances on the outside of the tank, the press lines and the cable tray? Do you want no movement, or can they flutter a little bit, or is your main concern that something would rip off and become a source of debris itself? I'm trying to figure out really kind of what it is you need to fly safely.
Well, in the ultimate analysis, we don't want the parts to come apart. Let me see if I can put that in the right words. There's normally some movement. I think if you looked at the video from the last flight, we detected, you could see in the video vibration in the big 17-inch line going uphill, which we're not too worried about. Clearly, some movement is acceptable. Too much movement leads the structure to the point that it would yield and come apart, and that's not acceptable. And that is exactly what the dynamics, the structural analysis are off doing. It's not just, add up a row of figures to understand whether or not a part is has reached its mechanical limit. It's much more sophisticated than that, and it takes more than a couple of days to do that work. So the folks are off looking very hard at exactly how much movement they would get, how much displacement, how much force, and whether or not that's acceptable. And the key question, of course, is we cannot have any parts coming off the vehicle, and we certainly don't want to cause a leak in one of those press lines. So at the final analysis, we will take some movement, but we won't take parts coming off.
Are there any further questions?
Some weeks ago during a briefing, there was an issue about oxygen levels in the aft compartment. Has that been closed out yet?
We're getting close to that closure. There was a report. We have 6 little bottles that are vacuum bottles in the back end of the orbiter. They're opened during different stages of the launch profile to capture a sample of the atmosphere in the aft compartment. It turns out that 2 of those bottles had a reading that was indicated to be unacceptably high in oxygen and could in fact mean that we have flammability concerns. To have a fire, you have to have 3 things. You have to have oxygen, you have to have fuel, that is to say something that will burn, and you have to have a heat source. We know in the aft end of the Space Shuttle orbiter, in the engines and the auxiliary power units, we have heat sources that can ignite things. We have no fuel back there. We have nothing that can burn. However, a leak from the hydrogen system or the hydraulic fluid or any number of things could provide fuel. We think we've got those all controlled, so we don't think that we'll have a fire. Now, the third leg is the oxygen. We try to purge that aft compartment with inert nitrogen gas so that even if you have 2 of the 3 legs of the fire chain, you wouldn't have a fire. What we saw was an indication that perhaps there was a small oxygen leak in some component that would again, provide 2 of the 3 legs, but not the third leg for fire, which is something that's very undesirable. In the meantime, we have gone back and looked at the analysis on those bottles, and we believe that we found an error using an incorrect calibration curve on the equipment that did that analysis, and we believe that applying the correct calibration curve, the oxygen content in those bottles is below the flammability limit. Now, that's the good news. The interesting news, however, is that it is still higher than we normally expect, so there's more work going on, and it's not completely closed out, and I'm sure we will get to talk about it some more. In the meantime, the really interesting part of this is we had taken apart several of the systems in the back end of Discovery. We've taken the engines out, for example, and what we have improved our process is to make sure that we get a report of any potential or indicated oxygen levels before we start taking apart any of those joints which might have in fact been a leak source. We had no indication of leak source. We cannot find anything that was leaking then or we think could be leaking now, but we're going to continue to look at it. So a long answer to a short question, we have not completely closed it out yet.
With Interspace News. This is for Wayne. I have one question and a follow-up. I've heard a lot of conflicting information about, I guess, what would be characterized as an IFM developed for bringing a stranded orbiter back down. I was wondering if you could describe the package. I guess it was developed in-house here at JSC. Describe the package, how it interfaces with the orbiter, and which non-GPC functions it's designed to take care of.
That was a contingency thing that we asked some folks to go off and take a look at. They built a test set of cables, and we haven't approved using that yet. There's some of the things that an orbiter, cannot be landed automatically or without people on it today include things like lowering the landing gear, which is kind of important if you want to get your orbiter back, getting the air data system to operate, 3 or 4 other things. I don't have the full list in front of me, but I know we had a team of folks that were off looking at that. It's difficult for me to envision the circumstances under which that kit might be used, but it has been under development, and frankly, I haven't checked on it lately, so I can't give you the status.
Okay, sir, and the second question, I hate to go back to the MPS pre-valve screen. I just want to know, what does the presence of that debris tell you about the health of the system upstream of the screen itself and the main plumbing?
Well, let's see. Given that we see occasional particles on those screens from time to time, it's a huge tank, you know, that's got a huge volume of fluid in it. That gets pumped out into the engines in a very rapid manner, and the reason for having a screen is kind of the same reason that you have a filter in your home heating and air conditioning system, is to try to keep stuff from going down into the moving parts of the system. And my observation is it's done quite well, and that we find quite few particles. Clearly, we've never had a problem in flight with these particles. Now, that's not flight rationale. But it is an indication that the screens are doing what we ask them to do. And from time to time, we find small pieces of tape or grease or metal particles on the screens, and have to deal with those.
That's all the questions from the centers. We'll go one more question, Bill Harwood, and then we'll wrap up.
Two quick follow-ups. Can you give us your thinking on 39B and how that relates to a possible standby for a Hubble mission if you needed a shuttle to go? I mean, is that the reason Shuttle wants to keep that pad operational? And B, is the tank on the barge okay? I heard a crazy story about some noise in the tank that you guys were off looking at. Probably nothing to look at.
Well, I've been told that people hear noises on the barge quite frequently when they have a tank on board, and we did get a report. There were some popping noises. The tank will be thoroughly inspected when it arrives at the Kennedy Space Center and they open the doors and pull it off the barge. I have every reason to believe that if any untoward things happened, and I don't really think they did, but if there was anything, we would find it, and then we've got repair techniques or you deal with it. But the good news is we've got people that are paying attention, and they're willing to call us up and say, listen, we heard some things rattling around inside. And I would say that having a vessel in the ocean, you frequently hear things rattle around, if that happens. The other question was about the launch pad. Right. Well, we have the whole Hubble discussion ahead of us. While many of us would like to go service the Hubble Space Telescope with the shuttle one more time, we clearly have to demonstrate that we can fly the shuttle safely before we go do that. And Hubble flight would be some number of flights down the road, and whether or not we can come to enough confidence to say you don't have to be able to mount a rescue flight for the Hubble crew, because it is a completely different situation than for the International Space Station, where you have a nice place to stay, friends, food. It's a little bit different when you go to Hubble. We have that discussion ahead of us, and clearly if you want to have the capability to mount a rescue mission for Hubble, you need to have 2 launch pads, because the second shuttle's got to be out there ready to go. And so I expect that when we get approval, and most I said when, not if, because I'm optimistic, when we get approval to go service the Hubble again, we will have to discuss that topic as well.
One more question from Irene, and then we do need to wrap up.
I'm sorry to ask this, and I really should know, but I just want to make sure that I understand the power amp removal and the vulnerability of the equipment underneath it. Is this a situation that, should it rip off, it's a really bad day and it's a survivability issue, or is it a debris issue?
Anytime you have pieces come off your aircraft in flight, it's a really bad day, and therefore we want to absolutely make sure that no pieces come off in flight.
Thank you, and that concludes our briefing for today, and I appreciate you joining.
Good afternoon and welcome to the International Space Station Heads of Agencies press conference. I'm joined today by our heads of agencies. I'll have a short introduction, and after that we'll have some short remarks by our heads of agencies, followed by the question and answer period with the media. I ask that all media members, before asking your questions, please identify yourselves and your affiliates before asking and who you're directing your question to. Appreciate it. We'll go ahead and get started right now with introductions. To my left, NASA Administrator Michael Griffin. To his left, Canadian Space Agency Vice President for Science, Technology and Programs, Virendra Jha. To his left, European Space Agency Director General, Jean-Jacques Dordan. To his left, Japan Aerospace Exploration Agency President, Keiji Tachikawa. And to his left, Russian Federal Space Agency Head, Anatoly Premanov. As I mentioned, we'll have short remarks right now by our administrator and then by the heads of agencies, and then we will open it up to questions and answers. I now present you NASA Administrator Michael Griffin.
Good afternoon. This is an exciting time in the space program, not just for the United States space program, but for the space programs of our partner nations. The annual Heads of Agencies meeting is always a time of taking stock. This time, it's a good process. We've reached agreement as agency heads on the final configuration of the International Space Station with no major changes from the configuration you've come to know and love. The budget in the United States and the plans for the flyout of the Space Shuttle program support those agreements. The budget of this president supports those agreements. In that vein, then, we look forward to future success in returning the shuttle to flight, completing the assembly of the space station, using the space station to generate the kind of data and information that will enable our program of exploration to return to the moon and continue on to Mars after we have completed the station. And in so doing, of the member nations, as we have been doing and as we hope to continue to do. So it was a good meeting, a very enjoyable time to be here. And with that, I think I'll finish and turn it over to Virendra from Canadian Space Agency.
Thank you, Mr. Griffin. Good afternoon. From the Canadian Space Agency point of view, the meeting was very fruitful and successful. We are very pleased that the new assembly sequence meets our needs and those of all the other international partners. We have agreed roughly the timelines for the launch of the remaining portions of the Canadian robotic systems, which is contributing to the construction and maintenance of the space station. We are very proud of our contribution. We are also looking forward to the resumption of the shuttle flights and the upcoming flights of our Canadian astronauts. As we did in the meeting, we fully endorse the conclusions reached in this meeting and fully support the statements which have been released as joint statements. Thank you.
Yes, thank you. So I must say that today is another important step towards our consolidated partnership on the International Space Station. So last December in Europe, we have got renewed commitments from the ESA member states. We have got budgets. We have the willingness to cooperate among the partners, and as of today, we have a plan, a detailed plan, which is realistic and which balance the technical and programmatic risks. So now we have just to deliver. We have now some technical milestones in front of us, and as far as ESA is concerned, our short-term technical milestones are number one, to deliver the Columbus laboratory to Kennedy Space Center end of May this year. And we have to launch the ATV cargo vehicle in May next year. So we appreciate the results of this meeting. We appreciate the efforts which have been made by NASA to put back the shuttle on flight, as well as we appreciate the Russian efforts to maintain the exploitation of the International Space Station based on the Soyuz and Progress. As you can see, the most important result of this International Space Station is partnership, and each time we meet, I think that we consolidate that partnership.
First of all, I would like to express my sincere appreciation to NASA for hosting the head of agency meeting here. HOA was an important milestone for resumption of the International Space Station assembly and its eventual completion, and stresses the international element launches. We had a fruitful discussion today, and we endorsed a revised configuration and assembly sequence, as well as plans to operate and utilize the International Space Station in the international endeavor. I confirmed the HOA endorsed the ISS assembly sequence in which the IP element launches were advanced and resulted in the minimum impact on the Japanese module delay. I expect the new assembly sequence be implemented as planned. In Japan, JAXA has been steadily preparing for GEM operations and utilization, and is processing with its HTB development. Thank you very much.
Спасибо.
Thank you.
Российская сторона полностью сегодня поддерживает принятые решения по конфигурации МКС.
The Russian side today has fully supported the decisions made on the assembly sequence of the International Space Station and configuration.
Мы приветствуем усилия американских коллег по запуску соответствующих модулей.
We are very thankful, and we are welcoming the efforts of our U.S. colleagues on launching of the international elements to the International Space Station.
Мы договорились о том, что российский научно-энергетический модуль не будет выводиться, но вместо него американская сторона обеспечит энергопитание российского сегмента со своего будущего до 2015 года.
We've made an agreement with the U.S. side that the Russian science power platform will not be delivered by the U.S. side. However, the American side will make up for it by providing power to the Russian segment from the U.S. segment, starting with next year and up to year 2015.
Мы сегодня доложили ряд своих предложений и руководству НАСА, и руководителю программы, и были услышаны.
Today we've announced a number of proposals, and those proposals were addressed to the NASA management and other partners, so those proposals have been well heard and well received.
В целом сегодняшнее заседание оцениваю как наиболее успешное, потому что в его решениях содержатся конкретные сроки и конкретные действия. Спасибо.
In general, I estimate today's meeting as a very successful one because we've adopted a plan with very specific actions and very specific dates. Thank you very much.
All right, thank you. That'll conclude the opening remarks. Now we'll go to the question and answer section. We will open with questions here at Kennedy Space Center, and then we'll go around to the different centers that have media members also watching over NASA television. Let's go ahead and start right here with Craig.
Jack and Mr. Toshikawa, has the
assembly sequence moved both Columbus and Gem earlier in the schedule? And for Mike Griffin, where does the Gem and Columbus fall now relative to a Hubble servicing?
So yes, the Columbus laboratory will be launched according to the sequence that we have approved today. The Columbus laboratory will be launched on the 7th flight of the Space Shuttle, which means an earlier launch in the sequence of the Space Shuttle flights. And I must say that we appreciate the priority that all partners, and especially NASA, has put on the launch of Columbus.
Mike, did you want to comment on that?
I was waiting until Dr. Tachikawa had a chance to respond to Craig's question.
I speak in Japanese. 日本のジェンもですね、一つワンフライトアドバンスをさせていただいて、今のところ8番目のフライトということになりましたので、これを最初のステップにして、次、引き続き9番目および12番目と3つのモジュールがありますので、これを着実に予定通り打ち上げていただけるようになったということで、心強く思っているところです。
Now, talking of a Japanese module called JEM, J-E-M, we had the fortunate situation to have one flight advanced. In other words, we have 3 modules altogether, and the first one will be launched on the 8th flight. And following that, the other 2 modules will be launched on the 9th and 12th flights. And I do feel that this is very encouraging if all those 3 modules will be launched as scheduled.
And my comment in response to your question is that the Space Telescope servicing mission, again, if we conclude that we are able to perform it, is of course not linked to station assembly. So I regard the scheduling of the Hubble flight as being primarily a technical matter that will be best determined by looking at the needs of the telescope and frankly the details of the actual timing of the assembly sequence. So that will be settled largely within Space Ops under Bill Gerstenmaier. But this is an issue that has visibility at my level. I've paid a lot of attention to Hubble over the years, and I will be working with Phil to pick a schedule for that flight that best works within the confines of the station assembly sequence and best works for the Hubble. Right now we're looking at something in possibly early 08. But, you know, final details to follow. The first of those details is the issue of whether we can do that mission at all. And I have consistently said, you know, we need to get the return to flight sequence behind us before we can get to any other details.
Also, for media members to know that we're working on an updated diagram of the configuration and assembly sequence, so we will get that out to you shortly. After this press conference sometime in the near future. So we'll get that to you to help clear things up. All right, next question, let's go to Jay Barbary.
Dr. Griffin, if you can launch the first assembly flight August 28th and you have no setbacks, when do you expect to complete the space station and how many assembly flights are you looking at now?
If we launch as given the constraints that you say, then with no setbacks, 16 flights are required to assemble the station, and we would finish sometime early in fiscal 10. So we have, we believe, substantial schedule margin to complete our job.
Next question, right up front.
Randy Siegel, WSTU Radio. This is going to Mike and Mr. Perno. With the changing of the order and advancing certain parts, I would assume we would need to increase the crew size on board the International Space Station a little bit quicker than may have been intended. What plans do you have currently to increase the size and the number of people on board the ISS to take care of the science necessary with the new modules?
Well, the crew size goes to 3 with STS-121, and then to 6 in the 2009 time frame. You know, again, we're going to. Some of these questions could be more easily settled when you get a chance to look at the assembly sequence and scheduling of the manifest that we're going to give you very shortly, but don't have available for this press conference. So, but no major surprises there.
Yeah, I think that'll help answer a lot of questions once we get that to you. Okay, let's go second row right behind, next to Jay.
Dan Billow, WESH-TV for Dr. Griffin. Would you discuss and sort of review what the level of U.S. participation in the ISS will be after 2010? And also tell us whether any U.S. hardware will be left on the ground.
I'm not going to speculate about what we're going to do post-2010 with the station at this point. I'm not the best guy to do that. I'll let you get with Bill Gerstenmaier later on. It is our plan to fly most of the U.S. hardware, and in fact, everybody's hardware. The station will be completed.
Let's go to Todd.
Todd Halverson of Florida Today, one for Mike Griffin and one for Mr. Permanov. Mike, can you tell us what the trades were in advancing the international partner laboratories? In other words, do you push back the electrical power, or is less electrical power going to be available to the international partner labs as a result of moving them up, or at least initially? And for Mr. Permanov, I'm wondering if you could go over for us what proposals you made to the partners during the meetings this week.
I'll go first. Again, same answer as I just gave. If we're going to get down into the details of the assembly sequence, I'd rather let you work with our head of space ops, Bill Gerstenmaier, on that. We certainly are not going to put up modules, however, that cannot be appropriately supported with power and thermal conditioning by the infrastructure elements of the station. And again, I'll let you pursue further details as long as you and Bill can stand each other. And Mr. Permanov, I'll defer now to you, sir.
Thank you.
В соответствии с той конфигурацией, с теми решениями, которые сегодня были приняты.
According to the configuration and those decisions which have been adopted today,
действительно, я подтверждаю слова господина Гриффина о том, что российский модуль будет обеспечиваться с американского модуля энергетикой. Ее хватит до эксплуатации станции как минимум до 2015 года.
And I would like to confirm the words of Dr. Griffin here today that the Russian module will be provided by the power from the US module, and that power level will be sufficient, and it will go on like that till 2015.
Что касается конкретных элементов договоренности и самих дополнений и контрактов, то они еще не подписаны, они сейчас прорабатываются и будут подписаны в этом году.
As far as any specifics or any specific details of the contracts and different documents are concerned, we haven't really signed anything. We are still working on the details of those documents, and they will be signed in the nearest time during this year.
Кроме этого, мною было сегодня предложено рассмотреть ряд моментов в области транспортного обеспечения МКС.
I've also made some proposals with regard to the transportation flow to the ISS, cargo flow to the ISS.
Создание резерва кораблей типа «Союз» и прогресс.
I've proposed to make a stock of vehicles, of Soyuz and Progress vehicles.
И другие вопросы, которые взяты на проработку в течение этого года.
And also, they've been a number of other issues which I've raised, which we've decided to walk through during this year.
Спасибо.
Thank you.
All right, we're now going to take a break from questions here and go to headquarters in Washington, D.C. We'll come back to Kennedy Space Center for further questions in just a moment. We'll start off at headquarters. Again, please announce who you are and what your affiliate is and who your question is for.
Keith Cowling, NASAWatch.com. Question for Dr. Griffin and Mr. Permanoff. In a few months, a cosmonaut is going to go out and do an EVA, knock a golf ball off of the International Space Station. At the same time, NASA is going to be canceling a significant amount of research that was going to be done on the space station, research that was promised for decades and indeed was cited as the reason for doing it. In addition, space science is being cut back, as we just heard in the hearing a few minutes ago up at Capitol Hill, to pay for this. Is this the right message to be sending to taxpayers in America, Russia, Europe, and Japan, that it's okay to do a stunt like this, but cutting back on the science? And indeed, is this worth the billions of dollars and rubles and yen and euros that have been spent on this project, where stunts are more important than science?
No one is saying that stunts are more important than science. We are doing all of the science that our budget allows us to do. And I think you know that quite well because we've had previous discussions on this. If we had a bigger budget, we would do more science. We're doing what we can. In fact, the partners, per the terms of the intergovernmental agreements, have the right to propose, and to conduct commercial activities on the station, provided that all appropriate safety considerations have been dealt with. We are not at the end of that particular road as yet, but we will pursue it. But should there not be a safety issue, then the effort proposed by Roscosmos is a revenue-generating opportunity, not a source of expenditures. And so I do not see it as being opposed to scientific or engineering research at all.
Mr. Permanoff?
I would like to confirm the decisions which have been taken in that regard.
И тот, кто задавал вопрос, конечно, прав, что мы во главу угла ставим сейчас доставку оборудования на МКС.
Definitely, right now our priority, and it's correctly said, our priority remains to deliver the hardware to the station.
Но дело в том, что это благодаря доставке этого оборудования и научных модулей, именно тогда может активно начаться и продолжаться научная деятельность на МКС.
However, it's due to the delivery of that hardware and scientific modules that will give us a better chance to continue and develop well the scientific programs on the station, conduct more research.
Поэтому наша задача как раз и будет выполнена в области науки, если туда научные модули будут доставлены как можно раньше, они на самом деле сдвинуты сейчас влево.
I think it will be better for all of us if those modules which are planned to be delivered will be delivered there as soon as possible, and if we push that schedule to the left, that will be to all of our benefit in terms of the scientific research.
Спасибо.
Thank you.
Okay, I think we have one more question at headquarters, and then we will go on to Marshall next.
Kim Yoshimoto from Kyodo News for Mr. Tachikawa. Please allow me to ask him a question in Japanese. 共同通信の吉本と申します。立川先生にお願いします。今回、日本に決まった3つのフライトの 何年打ち上げというのを一応、理事長から直接ご確認いただけますでしょうか。それから、一つフライトが、前に動いたということですけれども、これによる、運用面でのプラスの影響、あるいは電力面などを含めたマイナスの影響など、今考えられることがありましたらお聞かせください。
はい、それでは日本語でお答えします。日本のジェムの打ち上げ年度は、先ほどの順番で8番、9番、12番ですが、年としては8番と8番は2007年、9番と12番は2008年を想定して打ち上げていたことになります。で、このスケジュールに確定しましたので、我々としてはこのスケジュールにのっとって利用実験を着実に進められるようにこれから準備に入りたいというふうに考えています。前倒しになったことによるメリット、あるいはデメリットというのはとりあえずはありません。このスケジュールで着実に実験を推進できるようにしたいということであります。
The questioner said the following. I am Yoshimoto of Kyoto News Agency. Let me ask questions in Japanese. You talked about those 3 flights, and could you tell us in which years those flights or launches are scheduled right now? I'd like to hear that those years from your voice or your mouth. And also talking of that, one advanced flight you mentioned, would that advancing flight give any kind of positive or negative effect on the operation, for example? Can you think of any positive advantages or disadvantages of having advancing the flight schedule? Then Dr. Tachikawa said in answering that question as follows. Speaking of the exact years of the launches of those 3 flights for GEM, as I said earlier, we will have the 8th, 9th, and the 12th flights to launch those modules, and the flight 8. That will be launched in 2007, and the 9th and the 12th flights are scheduled to be in 2008. And now that the launch schedule is established, we would like to start preparation for steadily making the progress in utilizing that module for experiments. You asked if there's any advantages or disadvantages by advancing the flight launch schedule, but for the time being, I don't see any disadvantage nor advantage. As long as that schedule is adhered to, we would like to make steady progress in utilizing that Japanese module for experiments.
I would ask reporters on any questions for the configuration or assembly sequence. Let's hold off until you receive the documents. That way you don't waste your question on something that we really can't get into details right now until you get the information. So let's do that. If you have a general question, let's focus on that for this particular press conference. Okay, I believe we have another question from headquarters. Let's go ahead and go to the Washington Post or the New York Times.
Warren Dewey with the New York Times for Mr. Permanov and Mr. Griffin. Mr. Permanov, what happens to the Russian segments after 2015? Where will you get your power at that point? And for, I guess, Mr. Griffin or later Mr. Gersenzang, does this mean that all 4 major power units on the space station have to be put up? And is there a possibility that even with all 4 full configuration power units, the space station is going to have a problem with enough power?
Спасибо.
Thank you.
Мы одним из сегодняшних предложений мы рассматривали вопрос, в том числе эксплуатации станции после 2015 года.
One of today's proposals which I've made, we've considered utilizing the station beyond the year 2015.
К тому времени, конечно, будет ясно участие всех партнеров, в том числе и НАСА, и их роль, и вырисуется то техническое положение, в каком будет станция к 2015 году.
And actually by that time it will be clearer what will be the role of NASA and other partners in that program, what will be the technical status of those programs, and where we all be by that year.
И если, естественно, НАСА выйдет из программы после 2015 года, то технически все системы и агрегаты останутся на станции, то обеспечивать электроэнергией, энергетикой и российский модуль это технически возможно.
So if NASA decides to leave the program after 2015, and however, if all the modules and hardware is in place, technically it will still be feasible to provide power to the modules.
Но сейчас говорить об этом, я думаю, рано, потому что каждый год вносит свои коррективы, и мы ждем все полета первого шаттла, вернее второго уже шаттла, для того, чтобы все увидели, что эта программа двигается в положительном направлении.
However, it's hard to say because each year brings corrections to the program. So right now we are all looking forward to the second flight of the shuttle after the resumption of flights, and we will see after that how the program progresses into the future. Thank you.
I'm not really going to add to Mr. Permanev's remarks. I think it's a matter of speculation as to what the program will do in 2016 and afterward. That's 10 years from now. The efforts I have are focused on getting the space station assembled and safely flying the shuttle while we assemble the station, and then we'll move on from there.
All right, one last question from headquarters. I believe it's Guy Gugliotta from the Washington Post.
Yes, for Mike Griffin. Mike, could you give us your latest estimate on the likelihood of the shuttle next flying in May? And can you talk in a little bit of detail on how much more delay in shuttle flights you can handle before you have to start dropping flights?
We are working a schedule as of today that fits with the last part of the May window, and we're pressing hard to make it, but we're not pressing so hard that we would do something silly. We are trying to be, and we believe we are being, aware of technical considerations in preparing for flight. Whether we fly in May or fly in July, 6 weeks later, is from the point of view of the number of flights remaining this year and from the overall assembly sequence is essentially irrelevant, except that it's always better to do things sooner rather than later. We expect to get 3 flights in this year, but we can manage just fine if it's only 2. We have substantial schedule slack at this point, almost a full year of schedule slack in terms of the number of flights required to complete the station, and so we would have to have substantial difficulties that we do not now envision in maintaining our flight rate in order to start any consideration of contingency plans.
All right, that wraps up our questions from headquarters. Now let's go to Johnson Space Center. I believe Mark Crow of the Houston Chronicle.
Thanks. It is Mark Carreau from the Houston Chronicle, and a question and a follow for Dr. Griffin and perhaps others if necessary. But how do the changes you've made today satisfy or improve the space station picture? What is it you've done by moving up the labs that benefits the space station?
Mark, I think everyone is focusing on, you know, quote, moving up the labs, unquote, inappropriately. There has been some minor adjustment of the sequence. What you're seeing today as the output of this Heads of Agencies meeting is the result of 10 months of work between the United States and our partners, following my comments immediately after being confirmed as administrator that a 28-flight shuttle assembly and utilization sequence was not possible within the remaining lifetime of the Space Shuttle program, that we simply did not have the flights in the system to be able to do it. Not everyone agreed with that judgment, and I regret that, but that was my judgment. And so we focused on redefining the station assembly sequence, in fact, to concentrate on assembly. And we are largely deferring utilization, and we are paring logistics to the bone. We don't like that. But confronted with a choice between having a high confidence to be able to complete the assembly of the station and deferring utilization, or utilizing it heavily as we built it and possibly not finishing, we chose the former course. Now, as a result of taking that course of action, meaning to assemble now and utilize largely later, there has been some adjustment to the flight sequence regarding the labs, and you will, as we've said repeatedly, get to see that. We're not hiding it from you, we just don't have the graphic to give you at this moment, but you will have it shortly. The main thing that you're seeing here today is not adjustments in the flight sequence, but the decision to put together an assembly sequence that allows us to have very high confidence that we will finish the space station assembly by the time the shuttle must be retired.
All right. Mark, I believe you have a follow-up.
Or maybe not.
Brief follow. Do the plans call for the shuttle to do crew transfers, or will that go to the Soyuz, or a combination as in the past?
Well, obviously a combination, because the very next flight is bringing a crew member up on station, and we'll have a crew of 3 following 121.
All right, that wraps us up at Johnson. Let's go to Marshall for one question, and then we'll come back to Kennedy Space Center for a couple of questions before we round out the press conference.
I am with WSN 48 News here in Huntsville, Alabama, over at Marshall Space Flight Center. This is going back over to the May launch date, that window, and my question is for Dr. Griffin. I understand the external tank just arrived at Kennedy just a few days ago. There were some changes made. How confident are we that some of those changes that were made will swing us into that making that May window?
The external tank did arrive yesterday. If I wasn't being tied up with this press conference, I'd be able to go over and take a look at the hardware. We do plan to make some changes to the foam configuration on the ice frost ramps to minimize the amount of foam which could fall off the ice frost ramps, while still making sure that we keep the outer surface above the freezing temperature so that we don't accumulate ice. The details of those either have been or soon will be made available to you. We don't see that as a schedule driver, quite frankly. What we are doing that may, and I will say may, and I will say again, may affect the schedule, is subjecting these changes to wind tunnel testing before we make them. And depending on the results of the wind tunnel testing, we might decide that the suggested changes are a good idea, in which case we're solidly on track, or we might decide that they're a bad idea, in which case we won't make the changes, but we won't necessarily know exactly what it is that we do want to do, and then that could become a schedule driver. We'll let you know when we know, but right now our processing sequence is aiming at May because we want to fly expeditiously. We want to get back into operations.
That'll wrap up our questions from around the field centers. Let's come back now to Kennedy Space Center. We'll go to Mike.
Hi, Mike Schneider, Associated Press. I had a question for Mr. Griffin. As you know, the House Science Committee had a hearing this morning in which they talked about the money that was being taken away from science programs to make up for the budget shortfall for the Shuttle program. And a couple experts described NASA as at a, quote, tipping point where budgets through 2010 could do major damage to science research in the United States. What is your reaction to that assessment, and do you believe NASA is at a tipping point?
I think those assessments are wrong. We are trimming the rate of growth in our science programs to a 1% increase over the next 5 years, counting fiscal 07, after which, again, we would project that it could begin to rise in accordance with whatever top line the agency has provided. That does result in the delay of several missions and the cancellation of a couple of small ones. And again, you know, we regret that. We'd obviously like to be able to do more rather than less. We think the science program has had a tremendous history of returning great results. But we are in a period in history following the loss of and the recovery from the Columbia accident, where the human spaceflight program, to which we are also committed, needs help. We are trying to fly out the shuttle in an orderly and disciplined way to retirement. We're trying to use that asset while we have it to complete the assembly of the station in concert with our partners who have invested much. And frankly, those activities are activities which I have prioritized ahead of a more robust growth in science. We also seek to replace our human spaceflight capability, and that too must be done in a timely way. The ultimate choice is not whether or not the United States is going to have a great space program. We are. The fact is that something must be delayed. We, before accepting any delays in our science program, as I've said repeatedly, we delayed the crew exploration vehicle, the shuttle replacement system, to the maximum extent that I thought prudent. At some point we had to say we are done delaying the crew exploration vehicle and we will have to delay other things. And that's what's been done in our science program. But to describe that as a tipping point is a reaction that is almost hysterical. It is beyond any reasonable assessment of the quality of our science program.
Right up front. Yes, Stefano Golden, Time Magazine, and for Dr. Griffin and Mr. Dordain. Dr. Griffin, which was the most difficult decision you had to make in order to all agree during this couple of days of meetings? What was there any discussion that was pretty lively, or?
I don't believe that there have been any difficult decisions to make. There have been obvious decisions to make which are painful to implement. Things which are painful to implement often are deferred. But we are at a point in planning the flyout of the shuttle and the station assembly sequence where those decisions had to be made. I think it was a very obvious decision to design an assembly sequence which would focus on the assembly of the station so that by 2010 we would have a completed space station, and to defer the full utilization of that station until afterward, as opposed to taking a chance, as I said earlier, by trying to cram more flights into the sequence, taking a chance of not finishing the assembly. I think that was a very obvious choice. As with the comments I just made about deferring some science programs in order to finish the space station, these are painful choices. But the painfulness of the choice does not render it less obvious.
In Kourou, you are building a launch pad for Soyuz rockets. Does the European Space Agency intend to purchase Soyuz vehicles and launch them from Kourou with astronauts on board?
For the time being, there is no plan to launch any astronauts from Kourou. We are putting in cooperation with Roscosmos. We are building up a launch pad in Kourou for launching Soyuz, but for the time being is just for launching satellites. Now, never say never. We shall see. But for the time being, there is no plan.
All right. A few more questions here.
David Waters from Central Florida News 13 for Mike Griffin. You've been here a while now at the agency. You've gotten a huge grasp on everything that's going on, the inner workings. What do you think is the toughest challenge that you face ahead for the agency and the agency in general and the worker space here?
Well, I don't have any difficult challenges because I'm not doing any of the real work. The guys who are doing the real work are out there today wrestling the external tank into a holding cell so that they can work on it and later mate it to the shuttle. So our challenges as an agency are to basically do what we've said we can do. When we look at our own statistics maintained internally with regard to our shuttle operational sequence over 114 flights, as of this April 12th, that equates to an average rate of 4.56 flights per year for 25 years. And that counts 2 accidents and the recovery time from those, as well as numerous other stand downs for things like flow liners and wire bundles and stuff like that, that is lost in the recesses of my memory, but which I'm sure you can dredge up. So given all of those things, we've had that flight rate. Now, if we can maintain that flight rate, our average over 25 years, for the next 5 years, 5 fiscal years, we will easily complete the station. So that's our challenge, to do what we have done in the past and to do what we say we can do. And I really am, I'll be watching with you, because the people who are on the line to accomplish those jobs, you know, turning the wrenches, writing the code, sitting on the consoles, those are the people who have the work to do.
All right, have all reporters. I think we have one reporter that hasn't asked a question. And all right, Todd, we'll go to you as well. So let's go ahead.
Rory O'Neill with Metro Radio Networks. From the panel, we've heard terms like within budget and meets the needs and realistic. Is this the space station in 2010, when this, if everything goes on schedule, is completed, is this the space station and the scientific platform that was envisioned to do the robust and aggressive kind of research that was planned 20, 30 years ago?
Yes, it's the same space station. As you'll see when you see the sequence, you know, the hardware all goes up. For about the 3rd time, what we are doing is we are deferring the utilization of that station, largely deferring the utilization of that station while we concentrate on building it. Our earlier plans, which were better plans, frankly, allowed us to utilize it as we built it to a much greater extent than we can now accommodate. And that's the difference that you're seeing. But the end product is very much as we have envisioned it.
Todd?
Todd Halverson of Florida Today for Mike Griffin. Mike, can you give us a sense of what the spares situation will be on station at the end of assembly, whether or not you'll be able to leave gyroscopes and other critical hardware up there for the years beyond 2010?
We are looking at the pre-positioning of spares using whatever payload capability the shuttle fleet will have over these assembly flights. We don't have final answers yet. We are, of course, also, as you well know, looking at the creation of commercial logistics capability through the COTS program, Commercial Orbital whatever services. What I keep calling commercial cargo and crew, so I don't have to remember an acronym. Our international partners also are bringing to bear with HTV from JAXA and ATV from ESA, are bringing to bear substantial resupply capability. Our Russian partners have steadfastly sustained the station while the shuttle has been down. They too have capability. This truly is an international product led by the United States, but an international project that I think we can all be proud of. And we will find a way to make sure that the logistics and spares issues are dealt with appropriately.
All right, we have one last question here. I think it's Dan.
Yes, Dan Billow again from WESH-TV for the ESA Director General. Would you please talk a little bit about the ATV and its schedule and capabilities? I believe it was supposed to have been launched last year, correct me if I'm wrong. And also, how many shuttle flights do you understand are on the table here between now and 2010?
For the number of shuttle flights, I think that it's much better to ask my Griffin, because I am not in charge of the shuttle flight. But you will see the assembly sequence, and as Mike already said, the assembly sequence is based on 16 shuttle flights. And for the ATV, the plan is the following. We plan to complete the development and fully qualified on ground the ATV by the end of the year, to ship it to the Kourou base beginning of next year, for a launch which is today planned for May 2007. But obviously the date of the launch of ATV is not independent from the assembly sequence, because the ATV must arrive at a time when, number one, it is possible to go to the space station, and number two, this is useful for the space station. So this is today the plan. The cargo that the ATV will bring to the space station is around 10 metric tons of cargo.
All right, that's going to conclude today's Heads of Agencies News Conference. Appreciate everybody's involvement and questions. As I mentioned, we'll have the updated diagram of the configuration and the assembly sequence available shortly. For more information, please go to our website at www.nasa.gov. Thank you very much.